So let's go for it. So first thing, it's my name. I always like to start with this slide. It's a little bit crazy, but I think that you will get it. So this is Gerard Sanz. So this is my name. It's quite difficult to pronounce, so that's why that's why I want to start with it. Right now, I always usually show like my experience. So I'm going to be quick. So I'm a developer advocate for AWS, and you can see here some of the pictures that I took with cat, and also with this funny T-shirt that I made, developer. I don't know if you know about it, but yeah, I'm an international speaker, and I've been the other day I was looking at how long I've been doing this, and it's been like 7 years now. So it's a little bit crazy, and you can see that I've been almost everywhere. I mean, I was very lucky. That was just before the lockdown, and you can see that I've been almost everywhere. And today it's going to be the 152 event that I've done in 37 countries, which I think it's awesome. So let's start. And one thing that I want to mention here is, okay, so let's think a little bit about what is offline first, because it may seem easy for some people, but maybe you are wondering what that means. And offline first is basically this. All right, so maybe you are familiar with the dinosaur. And when you are offline, actually, if you press the space bar, you can play this game, which is the dinosaur just jumping cactuses. So how awesome is that? But I mean, if you have an application that you want to share with your users, I mean, it's fine that the user can play the dinosaur, but probably you want them to use your app, isn't it? So what we are going to talk today is how we are going to make a View app able to work offline, and what are the challenges of making that possible. So let's look at what offline first for web means. And the first thing is, obviously, we don't want to see the dinosaur, so we want to use the app. I mean, if you build an app, you don't want the user to be looking at the dinosaur. So that needs to be offline ready. That's one of the requirements. The other thing is, you also want the user to have a great experience. You don't want the user to just see, like maybe some people say, like, okay, I'm gonna put like some page with a message like, okay, the application doesn't work offline. I mean, that's better than having the dinosaur, but that's not the best experience, is it? So it needs to be a good user experience. And that means that we will have to bring some native-like features, which probably we are not so familiar with. And if you think about it, what is the thing that needs to be working while offline? And one of the things besides, you know, the JavaScript code, it's probably gonna be the data. So that's gonna require some kind of reliable storage. And we're gonna see how we can use progressive web apps to solve some of these challenges. But these are mainly all of them. So we need to be able to run the application offline, and we need to be able to interact with data. And this data needs to be secure. All right, so that's the end of the first section of my talk. And I always like to congratulate you, you know, to go so far. So pat the back, you did very well. And of course, if you have any questions, you can ask me later. Okay, so one thing that we are going to look at is progressive web apps. And why? Well, progressive web apps will give us a lot of the features that we talk about looking at offline first. So let's see what that is. And here I want to show you in this axis, we have on the left side, we have capabilities, and on the right side, we have reach, like in how many devices we can run our application. And here on the left, I can show first native applications, and these are any applications that you run in your phone. And that usually has a lot of capabilities. I mean, you can have geolocation, activate access to your phone information, and on the device you have a lot of very performant and advanced features. Another thing that we can look at is where progressive web apps sit in this axis. So in this axis, PWA will be just right in the middle. So we have some capabilities from native apps and some capabilities from web apps. So that will be our last. So web apps or single page applications, they have more reach. You can run these applications in almost any operative system and device, but you miss some features, some capabilities. So PWA just sit in the middle and they will give us some of the features that we need. So let's see what we need. What are the core requirements for PWAs? So one of them is the security. And that means that we are going to be using HTTPS, and that will give us this security that the content, the assets that we are going to be using in our device to run our app and also to manage our data will be secure. We don't want this information to be compromised because it can change the behavior of your phone. So that's a little bit something critical in applying this technology. The next thing that we are going to focus on is service workers. And service workers will be allowing us to run offline, and we'll be do like really smart things with the request and also with the data. And these are some logic that can run on the phone independently. So this is something completely new as a web developer that you will learn today. And then for last, we will be looking at what it's called the web app manifest. And the web app manifest, it just has the information for an application to run in different devices. So here I'm showing a mobile, I'm showing also desktop, and I'm showing also a tablet. So these are the core requirements, and we can look at how the service worker, how it works when it's online. And then we will see what's the role while being offline. So here we have a single page application which hosts this index HTML page. And then we have the service worker, which is just sitting in between the browser and the internet. So let's imagine we have this app with some JavaScript and some assets, and the index HTML will try to get these assets and will make requests to the internet to get these assets and show them in the browser. When we have a service worker installed, the service worker will look at these assets, will look at these requests, and if they don't appear on the local cache, it will let these requests go to the internet and bring back these assets. So one thing that we'll be doing specifically is adding the assets in the cache. And we will see how that works later. Once the service worker has stored these assets in the cache, it then sends this information to the browser. So this is the behavior when the service worker is online. But what happens when we go offline? I mean, this is the most interesting thing. And let's show the behavior when we go offline. So here in this slide, we can see the service worker just exactly how it was at the beginning, but now there's no internet connection. We are offline. But the user refreshes the page. Imagine you are going on the underground and just wants to get that application code and also the assets. So in that specific moment, the service worker will do something very crazy, which is it will look for the request on the cache, and if there is a match, like in this information, so I can use it, and it will give it back to the browser. So for the browser, the application is still working. We have done some requests. The service worker has intercepted those requests and provided the content for them. And it doesn't matter if we are offline, the application still works. So that's how the service worker will provide this feature, which is amazing. And I like to show these cats just to show the amazement. Like, oh wow, look at this. Maybe you haven't seen this before, so that's probably the reaction from some of you. So let's see how we can do this in our apps, isn't it? We want to use this technology, so let's see how we use that. But first, I want to introduce you to a technology which is AWS Amplify, that will allow you to build your mobile and web apps on the cloud. And we use this concept, which is full stack serverless. And you can see there's a unicorn, there's a cloud. I mean, this must be cool. And the idea is that front-end developers and mobile developers can use the cloud, and that means that they can do front-end and back-end while using serverless. So that's why we pick this concept, full stack serverless. So let's see how that works. AWS Amplify works for all these different platforms. So we have iOS, Android for mobile, and then we have for web different frameworks. So we support React, we support Angular and Vue, of course, and then there's also React Native. The way AWS Amplify works is it provides a framework, developer tools that we can use, and also the cloud services which come from AWS. In the middle, we will be using the Amplify CLI, which will allow you running some commands to create your app and be able to add different features. So how the Amplify CLI works? Well, we have just few commands. The first one is init. Just to start a new project, you will call Amplify init, and it will do the setup for you. Then you can start adding what we call categories to add and extend your application with new features using Amplify add, and then the name of the category. And once you are set, you can then push these resources that are just local into the cloud. So it will provision all of the services that you need to run your application. And then, of course, if you need to change or introduce any changes later, you can run Amplify update. All right. So let's see some of the categories, which are the features that you can use in your apps using AWS Amplify. So here are some of them. There's obviously, we can add authentication, we can access APIs, we support GraphQL and REST. There's also chatbots, analytics, this is extended reality, storage functions, hosting to host your web apps. There's also notifications. I mean, there's a lot of features you can use. And these are all of the categories that I can show you, but there's always more categories that the teams are working on. So here at the bottom, I'm showing some artificial intelligence. You can translate text into different languages. You can also use Poly, which will take a text and then speak it out. You can do the opposite. You can record a voice message and it will translate it into text. Recognition finds data into your images and videos. And then there's also Comprehend that will find metadata in documents. So it's a lot of categories that you can choose. What we are going to use today is the auth and the API category with GraphQL. So I guess that's a lot of information. I mean, some of you will be like, oh, come on, Gerard. I mean, it's going to be easy. It's not going to be that hard. So let me start building this app. And of course, you can also follow a tutorial. The application that we are going to show is a single chat room. So it will be a single chat room where people will be able to register and share messages. So it's a cool chat app, and it's built using Vue. If you want to use this URL, you can follow the tutorial there, and you will get the same app that I'm going to show you right now. So this is how it looks. And you just enter a message. There's different people. Here we can see a message from a couple of users, G-Sans, myself, and a robot. And then I also put to show how you can send the message, how you share the message, and also how to delete all. I mean, if you get a lot of noise, you can always delete the messages and forget about it. So here, maybe I can show you a little demo, isn't it? So let me show you a demo of what we can see. And this is the sign in. So I just sign in with my, my user. Let me just quickly show you how that looks like. And here, let me just enter my details. So this is the login, and this is a component that Amplify gives you. And that will be what the other users will also do, and then they can share the messages in this chat room. So this is a little demonstration of what we are going to build. And here, let me show you the architecture. So for any AWS Amplify app, it will create an architecture, which is all of the different AWS services that we'll be using. And here we are using a few of them. The first that I want to mention is AWS Amplify, and this will be a hosting where we will store our HTML, CSS, and JavaScript. And there's also CI/CD. So every time you do a commit, it will rebuild your app and send a new version so it can be shared with your users. There's also, from our authentication, we are going to be using Amazon Cognito, and that's what I demonstrated by logging in into the Chatty app. And then what we will be working more is how we provide this sharing capability. And we are going to be using GraphQL, and that's going to be served AppSync, and then the data will be hosted in Amazon DynamoDB. So that's the whole architecture of our Chatty app. So let's see how that will work. And maybe you're thinking, oh, that looks like quite a lot of work, but actually what you have to do is just run the commands that I'm showing here. So we will start setting up the project, Amplify init, and this is from the terminal. Then you need to run a similar command, now adding the authentication, Amplify add auth. And we do the same for the API. In this case, we are using GraphQL. So we just need to follow the prompts. It will be asking some questions, and you can then deploy this solution to the cloud with Amplify Push. So this is all you have to do. You can see the details on the tutorial, but let's see how we are going to get that solution working. The first thing we need to do when we use AWS Amplify is define the GraphQL schema. And for this application, we are going to use this type definition. And if you look, it has add model directive, and this is something that the Amplify team has added. So then it will create all of the resolvers and also all of the data tables that are required to support our Chatty type. And then we can see the fields. So we have different fields. We have an ID, a user. Also, we want to store the message that the user is sharing and the time that was created. If you are not familiar with this GraphQL DSL, I'm just going to mention that the question, how it's called, the exclamation, it's telling you that these are mandatory fields. So we have the ID, the user, and the message, which are mandatory, and the date, the timestamp is optional. All right. So that's a little bit of an intro. You need to create this GraphQL schema to get started. And we're going to be using Amplify Data Store, which is giving you that offline storage. And when we are offline, we need to be able to store the messages from the user somewhere. And Amplify Data Store will provide that feature. And here I'm showing you the developer. So the developer is going to be creating the models from that GraphQL schema. And that's going to be accessing this data store API. At this time, we are using the models. We are not using GraphQL. So that's the first step and what the developer sees. Then that will be accessing another layer, which is now using GraphQL, and that's called the storage engine. And the storage engine is going to be doing few things. It's going to be taking the requests from the data store API, and it's going to store that information in a data store. That data store can be different depending if you are working on mobile or web. And here I'm showing IndexedDB, that's for web, and SQLite if you are on a mobile device. So that's going to be when we are offline. And luckily for us, when we use Amplify Data Store, that's going to be built from our GraphQL schema. So that will be done for us. We don't need to do any extra work. And one thing, of course, that will interest us is how, when we go online, that data needs to be synchronized. I mean, if you think about it, you are offline, you write some messages. When you go online, you don't want to write the messages again. You want somehow the data to be updated without you having to do anything. And this is how Amplify Data Store will do that. So it will take the information from the data store and it will use the sync engine to do that. It will just send the commands through AppSync, and it will update the information in DynamoDB. And it's going to be using GraphQL. So that's pretty exciting. Let's see how you can use those APIs. And the APIs are not very difficult to use. So here we can see how that would look like. And this code is showing you how to create a message. So one thing we are going to do is we are going to import the data store and also the models that were created from the GraphQL schema. And we are going to use the data store save, passing that model, which is just our chatty type. And here I'm just using my user, creating the message. Of course, it supports emojis, and we can also create a timestamp. In this case, it needs to be an ISO string, and that's going to create our message. One thing that will happen is it will create the message in the browser using IndexedDB, and that's going to allow that message to be synchronized later when we get online. I'm going to demonstrate that so you can see the behavior later. How we query data, it looks like this. We're going to take a new concept, which is the predicates, and the predicate will tell the data store how we are going to query the data. And in this example, it's just asking for all of the records. So it's going to take all of the messages from the data store, and it's using that query API. All right. So now we are on the money, isn't it? So here, I'm going to show you another demo. So one thing I want to show you is I want to show you two things. So the first thing is how this information is going to be shared between the different clients. And here, let me see if I can put these two screens. Okay, just in the middle. All right, now it's just that middle. Okay, so here I have two instances. On the left, I have a Chrome instance, and on the right, I have a Firefox. And I just want to show you how these are working and how these are sharing the information in real time. Here I have my my user. This is another user, which is the robot. But because I created this beforehand, I can use my mobile. So let me send some messages. So hi there. So that message, as you can see, it appears on the chat room, and all the clients can see it. Now I'm gonna be using my phone, and here you can see that I have the same app. In this case, it's the robot. So I'm going to answer. And one thing that I can show here is I can also use emojis. I mean, it's easier anyway. So here, I'm gonna just write the message. And just to show you that I can write the message on the phone and it's being synchronized on the Chrome and Firefox. So now I have this setting, it's working, and I'm gonna do another thing. I'm gonna show you how that's being stored. So let's open the Chrome developer tools, and here I want to look at the application. You want to be looking at the application tab, and maybe let me do a little bit bigger. And here we can look at the indexed TV. So you will see application storage, and you can see this in your browser. We have a database, which is Amplify Data Store. And I'm just gonna pick the information that there is there. So here I can see the last message. This is the message from the robot. I can also see some private fields. These are the fields that the synchronizing engine is using. So then I can see that there's a tracking number. This is a timestamp. And also there's a version. So that's how Amplify is able to check the version of the different messages and replace them with the latest information. And when I get a version number, it means that every user has a copy of it. We can see the previous message. I'm speaking at Brazil.js, and also I can see the initial message, which is hi there. And all of this is giving me all of the information while I'm offline, because it's on the browser. But what happens if I go offline? And you can do this by going to the network and changing the setting. Well, here, if I go offline, I got the dinosaur. So that's not what we want. And obviously, that's something that we want to change. So let me go online again and show you how we are using GraphQL. So let's see that very quickly. And what I want to show you is I'm going to remove this, and I'm going to share another message. Just to show you how I'm creating the message. So I can see here the message. This is a test. So that I created with the data store API. And that was translated into a GraphQL. And here we can see the actual GraphQL query that was executed. So over here we can see a mutation that was executed. Let me see if I can move this a little bit farther. I'm not sure if you can see it, but that's the operation that was created by the data store. And yeah, that's more or less the workings of our chatty app at this point. So we can synchronize, we can share the messages, we have different users, they can use different devices, but the only problem now is that they don't work offline. They don't really work offline, and we get that dinosaur. So one thing that we want to solve is we want to create a progressive web app. We want to make our app a progressive web app so we can use it offline and also be able to use it in different devices, being able to install it. So let me show you how I did it for my app. The first thing that you need to use is the PWA View CLI plugin, and that is running this command that I can show you here. So this is view at view/PWA. And that's going to do a few changes. The first change is going to be changing your main JS file, and it's just going to add the service worker. So that's the main change. There's also some other changes that happen on the index HTML and also some assets for the different devices, but that's the main change that you will see if you run this command. And the first thing I want to ask you is to make a production build, which is using the yarn build, and then you will be able to see all of the new assets that you will have. And this is, of course, going to be published when you release your app, and this is the distribution folder. So here we can see the different assets. These are CSS, images, and JavaScript. You can see that there's some support already for images for Android. So that's going to make your app available for Android, for iOS, and also for the different operative systems, Microsoft, Windows, and also Mac and Linux. And here we can see how that will be done. One thing is by using the manifest that will give you all of the settings for different platforms. And the other thing is by using the service worker. So that pre-catch manifest I'm going to cover later, but these are the files that your service worker will be using and pre-catching, as I explained before. And of course, we also have the service worker. So some of these changes were made by the PWA View CLI plugin, and these are already working for you. So now that we have built our app, we just need to run it. And the way you can do this is by running this Python simple HTTP server. I mean, this is if you want to test it locally. You can also deploy it, but then, of course, if you do a small change, maybe you don't want to deploy every time. So that's going to be a little bit easier. When I did this, I got the app working, but I got my first issue. And my first issue was that some of the assets were not working. And this is one of them. So this is the logo. This is the AWS Amplify logo, and if we think about that, we can understand why. So a lot of the assets that my app was using were already on my public folder and part of my build, but this asset was completely outside of the compiler knowledge. So there was no way for the PWA CLI plugin to know about it. So what I had to do is add custom configuration, and that will give you that power. And when you are using custom configuration, you need to create this view.config.js. And here you can see how that looks like. Here is just using the manifest in our public folder. And then we are using that to define the settings for our PWA plugin. Some of the settings, as you can see, they are just the description of the application, how it will look in different environments. So this is for Apple. There's also the Microsoft tile color. And you can change this. You can customize it to the experience that you want in different devices. But the most important setting is just setting the service worker using this inject manifest. And we are going to create this service worker because I want to add that SVG, which is the image from the logo. So here I'm showing you how the service worker looks like. I'm just going to use this Amplify data store so I can look on the cache and I can see the assets there. And then I'm going to set it. These are some settings for the service worker. When you create a new version of your service worker, you have different options. The settings that I'm showing you in this slide, these are for updating to the latest version in any of the clients, and also skipping the waiting. So that's some of the settings. The most important bit is adding the asset that was missing. So this was all of the changes that I had to do to include that logo. One thing here in this last bit is I'm adding all of the files that I want to pre-catch. If you remember the slide when we show the service worker remember some of those requests. So this is adding this logo to that pre-catch content. So when I'm offline, that SVG will be available. So that's pretty much it. And I hope you have enjoyed. There's a little bit more work to do, and now if you release that new app with those changes, you will have a new PWA. So that's exactly what I wanted to show you. And now we will see how that will look like. Before I do the demo for this, just that what we have achieved by running that PWA CLI plugin is that now we can run this application using the web app manifest in different platforms. So now you can use it on web, of course. You can also use it in mobile and in desktop, which is quite cool. Once you have this released, you can share it with your friends. And this is one feature that you can use that is called add to home screen. So when you are in your mobile phone, you can navigate to the URL of your PWA app and choose that from the browser menu. And you can see two examples. On the left, I have an Android phone, and on the right, I have an iOS phone. So this is how it looks. This is using the logo, but you can change the logo, change it for any other icon that you like. And this is the same, but now demonstrating the app. So you can see the app working for mobile. And one of the nice feature from making your app a progressive web app is that you get a really nice performance. And you can imagine that comes from the pre-catch files, because the files are already on your browser. You don't need to go to the network, so that will make the application. And that's what you get. This lighthouse test, like really good. So we are passing that test, which is great. But there's still few things that don't work as you would expect. And that's why I'm calling 99% offline. Because one thing that happens is, okay, we can run the application offline, we can store the messages while offline, and this is what I've shown you with data store, with Amplify data store. We can also share the message when we get online, and I'm going to do a demo about it. But one thing that we don't show at this point is that the user doesn't know if it's offline. I mean, imagine you are on your phone, you go into a room which has no internet, and maybe you're still messaging, and then you realize that you have no internet. And that's not the best experience, is it? So I'm going to introduce some changes. And the changes that I want to introduce is, if we go offline, I want to show a message for the user. And the way we are going to use that is we are going to create a flag, which is going to be called offline, that we can use to show a message or change the UI. I'm going to use this code. So I'm creating this offline flag. I'm going to import what it's called the hub. So this is a event listener for the data store. And I'm going to take that information to change depending on the network status. So if the network goes offline, I can show that information to my user. So this is how it looks. We just show the input for the message. We show a message at the bottom. And let me just do a quick demo for that. Let me show you the final version. So this is the version that is released. And I want to show you the different things that we added to it. So the first thing is I want to show you from the application tab in the Chrome DevTools. I can see the manifest. So this is the information that we set for our app. We can see the different icons. These were added by the PWA CLI, View CLI plugin. You can change these to meet the different requirements. There's also the service worker. You can also see how the service worker is working. You can change the settings to make the service worker work offline. So let's do that. So if I go offline, you can see that now the UI has changed. It shows that you are offline and the messages will be shared later. So let's try this. I'm going to create some messages offline. This is a message offline. We are going into a place with no internet, but I still want to share this message. Of course, the message is not going to be shared. I mean, at this point, it's only seen by me. But one thing I want to show you is if I go to the network, I want to go online and show you how the data store is going to share that message the moment I go online. So here, I'm going to go online. And you can see here, there's few requests. There's the request from Cognito. This is for security. There's also a channel, WebSocket channel that it's going to synchronize with all of the different clients. And here I can see the last message. So you can see that the message that was created, it has been shared through WebSockets. So any of the clients have received that notification. And we can also see the operation that we did. Here we have a query operation. This is to read the messages just because we went online. And the other one is the mutation. So this mutation will be the one that creates, this is a message offline. So you can see here that the moment I went online, Data Store realized of that and create the GraphQL to first share the message with all of the different users and also send the mutation to create the message. So I think that's pretty awesome. And another thing that I want to show you is how we sorted the assets. So let's see that. So one thing that I want to show you is that all of the assets are now pre-catch. And the way you can see this is by looking at the network tab and looking at this column. You will see that all of these files are now being served by the service worker, as I show you at the beginning. And I'm most interested on the SVG. Not this search. I want to search. I want to find the SVG just to show you. All right, here it is. So that's the logo that now it's coming from the service worker. That's one of the things that I've changed. So that's working and it's coming from the service worker. So what will happen if I go offline? I mean, besides having the message, I also can reload and all of the information will be coming from the service worker. So also the logo, it's being shown. So we have now offline first application, which is what we were after. So that's pretty much it. Just want to give you like an overview. So if you want to compare web and PWAs, this is an overview. So obviously, if you are using web, it's a little bit slower because you always need to go to the network to use any assets. With progressive web apps, it's a little bit faster because we have the application pre-catch. There's also this difference between what can you do. So with a PWA, also work offline. There's also the experience of a full screen app. So now, if I go into my app, I can install it. So here, I can show this into to you. It looks like this, and because I installed the application, it will just open the application in my system. So that's the full screen application mode, and of course I also can access all of these different operative systems, there's browser, mobile, desktop. Your web app can only work in the browser, unfortunately. And there's also the native like features. So of course, you need to give it to PWA, which is, in some scenarios, it can be really good for you. So that's the end. And what I want to show you here is that everything is possible. We have this crazy cat doing the DJ with the universe as the background. So that's what I wanted to show you today, how you create a not so basic offline app. And this is how you do it. So at this point, I'm going to ask you to give it a try. And there's few resources I want to share with you. One is the solution, so you can see all of the code that I used. And if you want to follow a workshop style, there's also this resource. You can go step by step and build the chatty app using all of the techniques that I used. So this is pretty much it. So thanks a lot. It was a pleasure to join you, and I'll be happy to answer your questions. Thanks for listening.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I could see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the light gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth manager. He uses the most advanced financial technology.
All right. What if I set the parameters to look for equities in the energy sector? And here. Alert set.
William trusts DevExpert solutions help him with his trading decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to his friends.
DevExA. Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize his ideas in real time. But most importantly, DevExpert systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. DevExA, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. DevExperts will be there.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте! Аз съм Симеон и съм софтуерен инженер в SANAP. Тук е доста яко. Можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SANAP.
welcome to the WebGPU talk, and thank you for joining. WebGPU is a new experimental API for programming GPUs in browsers from JavaScript. And of course, for the full stack developers amongst you, I also have a small surprise at the end. So make sure you don't miss that. Our agenda for today is to look at the history of at least how we have been programming GPUs for the last 10 years. Then we'll look at a new family of explicit APIs, which is quickly gaining popularity. WebGPU is actually one of them. It can be considered one of them. We'll look into some examples, of course, and the hello world of graphical applications, GPU applications, is usually clearing the screen, showing a triangle, drawing a triangle, and we have like this internal joke that the third step is everything else. Of course, make sure to not miss the QA session. I'll be glad to have discussions with you about the potential of this new API. Maybe you have better ideas on how this can be used. I'll share mine, of course. But looking forward to a discussion, and if you have questions, of course, I'll be glad to answer. So very quickly about me, I'm a software engineer at EPAM Systems, which I would like to thank for supporting me into this endeavor of speaking and sharing knowledge. My main interest is generally about image processing and graphical computation. This is something that I've been doing for a lot of time now, and I really have fun doing it. So why GPUs? I could tell you my story of it, but NVIDIA during one of their conferences actually had this brilliant idea to make the Mythbuster guys build real-world examples of how CPUs and GPUs work. So the small robot you see is called Leonardo. It shows how a GPU, a CPU, this is actually the CPU representation draws. Now you can see it executes actions one after the other, and you can eventually increase the speed, but there's obviously a limit of that you cannot increase anymore further. So to illustrate the GPU, they built the second version of Leonardo that you see right here. And you can already anticipate how this is going to work, right? So this is just like the first version of Leonardo, but then you have many cannons that will be shooting paintballs all at the same time. So this is very close to actually the difference between CPUs and GPUs. The thing about GPUs is that, of course, they can be used for different purposes, so we need to tell them what exactly to do. So you see here in a single shot, we drew an entire frame, all the paintballs shot at the same time, and the only difference is their color. So it's like multiple data, single instruction type of workload. So what do we need to tell the GPU, say, if we need to draw a triangle, which is the goal for today's talk? For a triangle, we have 3 points that we start with, a red one, a green one, and a blue one. And we need to tell the GPU about these 3 points that we would like to draw. And this is generally done within a program that is called a vertex shader, and it's part of the vertex shading stage of the pipeline. So we're going to build a pipeline here to illustrate how it works, and this is the first stage. Points are also called vertices, of course, because triangles are primitives of GPU hardware. The next stage is telling the GPU which primitives to use for our points, because there are different primitives supported. There could be line strips, lines, points actually can be also primitives, and triangles. And this is done in the geometry shader, so a geometry program. in the second stage. And the third one is the rasterization stage. In here, starting from the shape that we have described, the GPU quantizes the shape space into single fragment units. And you can notice a couple of things here. One of them being the staircasing, which is where anti-aliasing comes into play. And the other one is a precision issue on the right. And this is very common when you build these types of applications. Based on performance, you might need different levels of precision. Lower levels of precision are, of course, much faster. So you need to make a decision on which side you would like to stay. But and then this problem is noticeable sometimes. You've probably noticed it in games. It's called pixel fighting, where the GPU is unable to determine which pixel is in front, which one is back, because it's difficult to calculate the distance with respect to another point. And the final stage is called the fragment shader stage, and it's being programmed via the fragment shader program, which we upload to the GPU. For every quantized fragment, we execute a program that determines the color. And this is obviously oversimplified for the sake of explaining it during the talk, but it does not get much different than this in reality, even with older APIs. This is generally called a fixed stage pipeline, and it has some limitations. We need to execute every stage, and this, of course, is not applicable to all the problems. Some problems have a different need, a different requirement, a different solution. Good. Do we really need another API then? And I will let you answer this question by yourself. And to do that, I'll tell you a little bit about OpenGL. So if you started doing graphics programming, say, a couple of years ago, maybe OpenGL was your only cross-platform solution. There is really not many specifications out there that can support graphics programming in different platforms. And OpenGL did have many issues, I would say. Some implementations deviated from the specification of the API. So when you build a graphics program, it would behave differently based on different hardware, based on different drivers. For me, this is one of the biggest pain points, one of the biggest problems that I had with my applications. Very, very bad thing. So in some Android devices, for example, the screen would flip its Y coordinates. So it leads to very bad user reviews, very bad feedback, and difficult to handle situations based on the huge device fragmentation out there and driver fragmentation. Besides that, so you can live with this, you can exclude some unsupported devices, of course, but OpenGL also had some performance issues. Why? Because the specification was hiding a lot of the internals. So using the API from outside, you just call one or two commands, and a lot of magic is happening under the hood. So in order to make this magic work, the driver implementation needs to do a lot of checks, do some synchronizations out of order, which led to stuttering, to bad frame rate, and so on and so forth. WebGL is, of course, an OpenGL ES-based web standard, and being based on it, it inherently gets all these problems. So this is why in 2013, AMD open sourced a specification for a new type of GPU programming APIs, the Mental API, which was supposed to be a low overhead, low low overhead, low level API for GPU programming, which led to these new families of APIs being developed. Of course, it has some disadvantages. Being more low level, it means that there is a lot of heavy lifting involved and a lot of manual work in order to achieve what maybe in OpenGL was a single instruction. But when you have the ability and the fine-grained control over what you would like to achieve with the GPU hardware, then you of course have a lot of gains in performance, for example. But it's not only that, as you'll see later. So one of the first APIs based on Mento was Vulkan, and Vulkan worked and it works pretty good on Linux-based systems, a little bit less on Windows. And to get it to work on macOS, you actually need some translations layers like MultiMVK. For Microsoft, they followed up with the version 12 of their DirectX SDK, and Apple came out with Mento. Now, if you follow the WebGPU specification, which I'm about to go through together with you, and then you check some of the Vulkan DirectX or Mento specifications, you will see that pretty much they follow the same principle that was proposed by the Mento API. So the same ideas, maybe the syntax is a little bit different, but not that much. And it's not about it's not only about performance. As I said earlier, sometimes your problem requires a different solution, a different pipeline. If you imagine, instead of starting with triangle points, you started from the screen pixels. So you start from here, and for every pixel, you need to query your 3D scene, the geometry in your 3D scene, and then based on the results of that query, you decide on the color of that pixel. You can see how this becomes a completely different pipeline that has almost nothing to do with our previous one. So we need to be able to configure the pipeline as well. It shouldn't be just a single fixed type of pipeline. And your problem might not even have to do with graphics and drawing or 3D geometry. Sometimes you would like to use your very powerful GPU hardware, highly parallelizable, to do some computation. So if you imagine having two matrices A and B, you might want to, you upload them to the GPU, but we might skip this step from, it's not actually part of the shader pipeline. You upload them to the GPU, and finally you compute, for example, you multiply one matrix with the other to get the result. So this is a completely different problem with a completely different pipeline. So it's not just about performance, it's also about being able to better utilize that hardware. So does this replace WebGL? Well, the answer is actually later versions, and now the WebGL API is much more mature, and it's definitely here to stay. It does not mean that WebGPU will completely replace WebGL. There's already a lot of existing software out there, but you just saw how WebGPU allows us to much better utilize the hardware and also solve a different set of problems. In theory and also in practice, you could implement these problems with WebGL. For example, you could treat your matrices as an image, as a texture, and still be able to do some computation based on that and read the results from an image. But you can quickly see how this is more of a hack rather than a long-term solution. So WebGPU is available under the navigator.gpu object, object, and these are the set of functions that are being exposed. Well, there's much more, of course, but for the time span of this talk, we'll just go through the functions that we need to draw that famous hello world triangle. So under navigate.gpu, you can request an adapter. So an adapter is an abstraction of hardware capability. And from that adapter, you can request access to the device. So this might be one GPU or multiple GPUs in an SOI configuration, which is now dead, but this is why this was in place. So it abstracts a little bit from the physical hardware. Then, if you remember in WebGL, we drew to a WebGL context on the canvas. This time, the context is now called GPU present, and it returns a GPU canvas context object. We always need some surface over which to draw, right? Then we have the concept of a swap chain. Now, swap chain is just a more is just a better way to make your drawing process and the monitor or your GPU and the monitor communicate a little bit better and avoid stuttering or slowdowns in frame rate, inconsistent frame rates. And what the swap chain actually is quite simple. So the idea is that instead of a single buffer where you render your images, you have two or more buffers, and every time you're ready with an image, you draw it on a free buffer or on the next buffer. So whenever the monitor is ready, it can also synchronize with the GPU, which is what G-Sync and FreeSync technologies allow it to do. And when the image is available, it can pull it and display it on the screen. So we have access to the swap chain. That's through the context. So we go context.configure swap chain, and we can also provide some options. What kind of buffers we would like to have, and so on and so forth. This returns the GPU swap chain. Sorry, I went back. Now, WebGPU, so these new families of explicit APIs, they are kind of declarative in terms of they expect you to specify the type of commands and the type of actions that you would like to execute on the GPU, and so that they can handle synchronization and memory in a more efficient way. So this is why we need to basically provide a set of commands that we would like the GPU to execute. It does not mean that they're being executed as we specify them. Rather, we build the pipeline and then we send it to the GPU. This is why we have a command encoder, which we can get from the device. And oops, I went back again. I have a tendency of pressing the back button. Not sure why. So we also need a texture or an attachment. You can use these terms almost interchangeably within the context of a fragment shader program. The attachment, for example, is, you can imagine it as the surface being drawn, as the texture being drawn, but you can also have input attachments, of course. So we need to get that, and the way to get it is going through the swap chain, getting a texture, and from that texture creating a view. So then we can pass this attachment to the shader program. Finally, we begin to specify our commands. So from the command encoder instance, we can call begin render pass if we are rendering, or for example, we can call begin compute pass if we would like to compute something. And we need to pass, of course, a description of the type of render pass that we would like to execute. When we're done, we call the finish method, and this finishes the recording of the commands that the GPU needs to execute. and it returns a command buffer. So these are the commands prepared, and we're ready to send them to the GPU. How we do that? There is a concept of QEs in these new specifications. So QEs allow you. So the difference is that you have, of course, different types of QEs. So you might have compute QEs, you might have render QEs, but you might also have a difference in terms of priority and scheduling. WebGPU provides us with a default QE where we can submit these commands, and we do that by calling the QE.submit and passing an array of command buffers. This is actually going to ask the GPU to execute those commands. It does not mean that they're going to be executed immediately, but we are requesting it to do so. So that's pretty much it. So all these functions allow us to at least clear the screen. There's a little bit more when it comes to drawing a triangle. For example, we need to specify a vertex shader program, if you remember from the earlier slides. And also we need a stage in the pipeline where we can actually specify what is the vertex shader, what is the fragment shader. But I'll also show you that as well. In terms of browser support, so let me show you how you can get access to this experimental web API in different browsers. On Safari, you need to make sure the developer options are enabled, and from there you go to experimental features, scroll down to WebGPU and make sure that's ticked. If you download the nightly version of Firefox, it's probably updating, that's why it's taking so much. Yeah. We go to about config. No. Yeah. And we search for WebGPU and make sure that enable is ticked. And for Google, you need to download the Canary version. Go to Chrome. And you have WebGPU. You can also use, of course, command line options to make sure these features are enabled. One thing that is very important is, because this is an experimental API, make sure you disable these experimental options, and once you're finished, and that you don't go surfing the internet with them enabled, because they still might have some security vulnerabilities. Actually, they most certainly have, so make sure to disable them. Now that we know how we can run a WebGPU program in a browser, at least how to enable the support, let's go ahead and clear the screen. So for that purpose, we'll use a blank React application. I'm going to open a terminal here, and we'll go, let's go to GMP. We'll make another directory, call it WebGPU, JSTalks, go inside here, and we'll create a blank React application. So npx create React app, and call it hello WebGPU. While we wait for this to finish, I'll open my text editor. Okay, and we also need to wait to open a browser, make it a little bit more. Let's go right here. Maybe this is okay, so that we get refreshes. I think the default was port 3000. No, because I did not start the React app. Okay, now it started. Okay, so this is the blank React app. What we're going to do now is go into the default app.js component. We'll remove everything. And if you remember, we need a canvas to draw. So we just create a canvas. Let's give it make it black by default, or maybe purple. Okay, like that. Okay, so we have our purple canvas here. Now, remember the steps. We need to get an adapter. So, actually, we need to do this after our component mounts. So we're going to use two hooks. One is use effect, and we also need to use ref because we need the reference to the canvas. And then we will let's have an empty use effect for now. Now request adapter. Okay, pass an empty array here. We only need to execute once. Request adapter and request device and some other functions are actually asynchronous. So within use effect, we will execute an anonymous function. Let's call it render, or yeah, render is fine. And we will execute this function immediately. Let me open the console here. I'm going to console log some things so that you can see the results as we write code. Okay, so the first thing is just to make sure everything works. And I didn't do some stupid typo. Okay, so we need an adapter. So navigator, if you remember, navigator.gpu is where our WebGPU object is. And from here, we need to request an adapter. And this returns a promise. And I'm just going to log some of the things that we write at the end. Like this. Okay, so you see we have a GPU adapter now. We need to get a device. That's actually from the adapter, sorry. Request device. We'll hook this one as well. Okay, so we have a GPU device in here. Let's get shorthand access to the QE. So if you remember, that was device.default QE. And finally, we need the context. Now, for the context, we need to use a ref. Here. Okay. So let's have a shorthand for the context. That would be canvas ref dot current dot get context. So from the HTML canvas element, we get a GPU present context. Let's log the QE. Let's log the context. And we need to use the ref to pass the ref actually in the render. So that would be ref. I call it canvas ref. So if we didn't miss something, we should log the QE and the context additionally. So we have the QE, we have the canvas context. Perfect. Next thing is to configure the swap chain. Now the swap chain, if you remember, it's a set of a front and a back buffer. So we'll create a swap chain constant. We get it from the context. So that's configure swap chain. And we need to pass a configuration object which has the device, but also the format of the pixels that we would like to use. So format is blue, green, red, alpha, 8 bits per channel, normalized, unsigned. Okay, and we should have a swap chain now. So this is how a pixel would be represented in that buffer. Cool, we have a swap chain. So this is pretty much our configuration part. We're done with the configuration now. And we're going to start encoding our commands. So we'll create a command encoder. For now, just use an empty object as options, and we need to get access to our texture view. Remember our attachment where the results are going to go, and we get that from the swap chain. Get current texture, create view. So I will log this as well. So we should have a GPU command encoder, and we should also have texture view. Okay. Sometimes I just type for the purpose of it. Okay, we have the GPU texture view and the GPU command encoder. So remember the step where begin our render process. That would be render pass, the render pass. And we do that from command encoder dot begin render pass. So here's the thing: we can specify some options in here. We can specify where, for example, the results go, but also how to initialize some variables. So we'll pass in a descriptor, and it can contain color attachments. So this is a descriptor, and you will find a lot of these descriptors in almost every single method of the explicit family of APIs. We have color attachments, of course, multiple ones, and we need to specify our texture view to be used as an attachment, and we can also specify how to initialize this memory, and this is in the form of, remember, RGBA normalized. So let's make our background red, for example. So red is 1, green is 0, blue is 0, and our alpha channel will be at its maximum value. Okay, so we are now beginning our render pass using some initialization values, and we get the render pass encoder, which I'm going to log here. Okay, we have our render pass encoder, and we're almost done. Bear with me. So we said that we would like to begin, but actually we wanted to just clear the screen. So there's nothing more that we would like to do. And at this point, we can simply end our pass. So we begin the pass, initialize the screen to some color, and end the pass. We need to get our command buffer containing the commands that we have just specified in the command encoder. Okay. And I will log this as well. Yay, we have a command buffer. And finally, we need to tell the GPU, please execute these commands specified in the command buffer. Save. And if we refresh our page, we get the red cleared screen. Good. So let's go back to the presentation, and the next thing, if you remember, is making a triangle. Now, in order to not waste too much of your time into technicalities, we have a, let me go to the screen again. Remember, we have a vertex. Oh, where did I put that? remember that in order to do the triangle, we have a vertex and the fragment shader. So these vertex and fragment shaders we also had, of course, in WebGL. And WebGL was able to take the text version of them and compile them in the GPU. But the new standard is that we actually provide the binary in an intermediate language that can then be sent to the GPU. That's called SPIR-V. And generally when we write programs, we write them in text. So there is a compiler built in WebAssembly that you can use. It's called GLSL Lang. It's built from the original GLSL Lang tools translate from GLSL, which is the normal shading language that we use in WebGPU, to SPIR-V. And it's a bit of a hassle to get it to run properly with Webpack. So you need custom loaders. I've already done that in this folder. So if I open this other project, so remember, it's the exact same thing, but I changed the Webpack configuration a little bit to include WebAssembly loaders. Yeah, so I override the default create React app with the library and tell it. Actually, that was a different dependency that I'm handling here. But it's essentially, we have the screen component, which was the app.js that we just saw. And this time I built a triangle component, which starts with the same structure. And I wanted to tell you what are the additional parts. So let me start this. Okay. So the triangle component, you see, nothing is changing in terms of React. We are still rendering a canvas. And this time we import the GLSL Lang module to compile our vertex and shader programs that you can see here into an intermediate binary, which is then used from WebGPU to pass it to the actual GPU hardware. So the vertex shader, and of course we have our points A, B, and C that we would like to upload on the GPU. So the vertex shader, if you remember from the previous slides, it needs to tell the GPU where these points are. So it receives an attribute, which is the XY location of our points, and it actually doesn't do anything else. It passes these coordinates that it receives in input, it passes them further in the pipeline. But this is actually where you would apply transformations and projections based on your camera settings and so on and so forth. The fragment shader, if you can recall, this is the part where we take every single fragment and we produce a color. You can also use different precision depending on your performance and hardware requirements. But essentially this says, I'm going to output a fragment color. It has 4 components, and the vector with 4 components has 0 for red, 0 for green, 0 for blue, and 1 for alpha, which is where this black triangle comes from. So in the fragments of this triangle, we have painted every single one with black. So this is the fragment shader program. Our vertices data, so X, Y, X, Y, X, Y. This is a 32-bit floating point array. What is changing? Not much. So we have the adapter, we have the device, the QE context swap chain. This time, remember, we need to compile the vertex shader program and the fragment shader program into a binary. So we use the WebAssembly version of JSLang, and we compile the vertex and the fragment shader. The output here is a buffer, it's a binary. We need to upload this data into the GPU. For that purpose, we create a buffer. Here we have the granularity where we can specify for which purposes this buffer is used, how it is expected to be used, so that the GPU can better manage the life cycle of this buffer. And nothing, we get the address and we copy our vertices to the GPU. Finally, this time we have a pipeline. So it's not just initialization as with the colored screen. We have a vertex and a fragment that we would like to execute. So we call create render pipeline. We specify which is the shader program which is the fragment shader program and vertex shader program that needs to run. And we can also specify a custom entry point. So the entry point we had here is main, but with the new API, we don't have this hard requirement, and we can change the function name. Remember, we need to specify some geometry, how these points get mapped into a shape, and the format of the attachments that are going to travel through. And you can jump this part, but essentially what it says is that it describes the data structure for our vertices. So what this says is expect 8 bytes from one element to the other. This is the stride. And that this memory needs to be copied to the variable at the first location. I will scroll up just to show you that this is location 0, where we receive the position in the vertex shader. No offsets, and the format is 32-bit float of a single element, if you remember that. And then again, we create the encoder, get the view, have the exact same descriptor. We begin a render pass. This time we set a pipeline for the render pass. We set our vertex buffer and we do a draw call. And we end the pass. So we record the commands that we would like to execute, and the save submission goes onto the QE. Refresh, black triangle. So everything else is up to you. But of course, you wouldn't do this by yourself generally. And I'll get back to that. But here's the bonus part. So I actually came to WebGPU from a completely different path and a completely different reasoning. So for the past 10 years, I've been trying to, as I said earlier, achieve a cross-platform graphics, like a cross-platform way to develop graphics programs. That it's very generalized because, yes, I had some ideas, but nothing much concrete. So, and there was none. But then when I heard about WebGPU in the very early stages, I actually tried to become part of the W3C, but there were some different requirements that I couldn't match for this process. But as it started to mature, I asked a different question, like, well, Google Chrome needs to support WebGPU, which is this low-level API, low overhead API. And I know about all the other implementations like Vulkan, Metal, DirectX 12. So how is Google Chrome going to do it? And this is actually where I'm very happy that I found about this project. So Google created a project called Down, and this is the rendering engine that's hidden below WebGPU. Like, this is what they use for their WebGPU implementation. And Down is a completely standalone project. So you can actually get the Down engine and you reuse your knowledge on native platforms. So you write in against the WebGPU API in whatever language you prefer, C, .NET, Rust, whatever. Node.js also has bindings for it. And you can execute graphics workloads on different platforms. So let me show you the project. It is open source. You can clone it on your machine, install Depot Tools, which is the Google toolchain for building their projects. And it's actually quite easy and quick to build. So you would get the folder from the Git repository. And if you look at the source code, you see it has a Down native folder with a bunch of implementations for DirectX 12, Metal, OpenGL, Vulkan. And here's the best part. If we go into some of the examples, like how to do a triangle in C, check this out. You have a device, a QE, a swap chain, a rendering pipeline, the format we saw earlier, exactly the same vertex shader. You compile them, a render pipeline descriptor. So it's exactly, well, there's a little bit more in here because the example is different and you can do, of course, much more in WebGPU. But the point is you can have take the exact same knowledge and transfer it into any platform. So I think it's rather cool, and I actually invest a little bit more into this project. I think it has a potential to help into many use cases, especially when some specific graphics behavior needs to be achieved within an application. For example, in a cross-platform way. So displaying a frame, we get a buffer from the swap chain. We specify actually the color attachment. We get the encoder, we specify our pass commands. Finish, we get the buffer. And we can submit to the QE. So let me show you this in practice. So I've already compiled the example, and it's within the out debug folder, see hello triangle. And well, we get a triangle running on like the graphics pipeline running on Mac OS using Metal, but all we had to do for this is apply our WebGPU knowledge. And I'll share some more links on the next slide. Press twice instead of once. So what's next? I wanted to share some links with you. Most of the 3D frameworks right now in JavaScript are getting support for WebGPU. It's either already implemented, it's being implemented or planned. So if you go with Safari to their WebKit demos, you can see some nice proof of concepts, a compute shader, which we'll look into a minute, and also the famous PBR helmet. So a physically based renderer can also work with image-based lighting and so on and so forth. A compute shader. So here's the example of the matrices we saw earlier, implemented in practice. So matrix multiplication, but let me show you first the code maybe, because it's very similar to what we already saw. You get the adapter, the device, you create a buffer for the two matrices that you would like to multiply. Then the shader is a little bit different. It's a compute shader. And we won't go into the details, but we compile with a compute flag. Well, essentially what it does here, it gets a reference to the two matrices, the result matrix, and the invocation ID, like which element it needs to do the multiplication for. This is a way to find your way out into highly parallelized applications where you can think of these like thread IDs, for example, and this is the matrix multiplication implemented. So instead of a render pipeline, we create a compute pipeline. Instead of a render pass, we begin a compute pass. And that's pretty much it. At the end, of course, we need to read the results. So matrix multiplication, at least the naive implementation of the problem is cubic in terms of complexity. It takes so much time. So with 512 elements, the GPU takes a little bit under a second. Now, generally, when my computer is not doing much work, right now I'm screen recording and so on and so forth, but it takes less than half a second, and you see the CPU took more than 7 seconds. If we do it with a little bit more, 1024, the GPU takes 1 second, and the CPU will probably take maybe 30 seconds or more. I cannot remember how much it took with 1000 elements, but believe me that if I do this computation with 2000 elements, it will take more than the end of this lecture, the time remaining to provide a solution. Yeah, finally, a very interesting project. Well, first, there is the playground that you can check. Somebody went and built a simple playground for WebGPU, so all credit goes to them, but they have some very, well, they provide you with an easy way to apply the knowledge that you have just learned about WebGPU, but you can also check out some transformations in 3D space and how it works, how they're being implemented. A very interesting project for the .NET developers amongst you is WebGPU.net, I believe. I haven't tried it, but somebody did the bindings from the Weave engine into .NET, or probably Weave themselves. But in a WinForms application, you can get the context, the surface on which you can draw with WebGPU, and you can do the exact same goals to achieve your graphics implementation. Okay, with that said, I'll leave the rest to you, and maybe you can play with some examples. 3JS also has some work in progress on WebGPU, quite amazing to look at. With that said, I would like to thank Tech Talks that also support me. As I said earlier, also they chipped in the driving conf, so that was a very interesting, an interesting collaboration we did. So yeah, please follow us in our next talks. It won't. So we have questions and answers sessions immediately after the talk, but time is limited there, I think. So if you want to have a longer discussion, I would invite you to this link, epa.ms vroom. We have organized a virtual room where you can chat with people from my company, but also with me. And we also have a very interesting game around Minesweeper. And yeah, I think it's interesting prizes for you as well. I think, if I'm not wrong, but the first prize was a drone or something. So you need to compete with me on that as well. Yeah, I'm waiting for you in the questions and answers meeting. And thank you very much for listening.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I could see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, with a light and a light to go. When the light gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is the most advanced financial technology.
All right. What if our parameters to look for equities in the energy sector? Right here, alert set.
William trusts DevExpert solutions to help him with his decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to his friends.
Devexa, show me Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize his ideas in real time. Most importantly, DevExpert systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. Devexa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. DevExperts will be there.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте, аз съм Симеон и съм софтуерен инженер в SumUp. Тук е доста яко, можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye. Yeah, well, I can see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster grows out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, where the light ain't allowed to go. When the light gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth manager, most advanced financial technology.
All right. If I set the parameters to look for equities in the energy sector, and here, alerts.
William trusts DevExpert solutions with his trading decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to his friends.
Devexa, show me Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize his ideas in real time. But most importantly, DevExpert systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. Alexa, buy 1,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. Experts will be there.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Аз съм софтуерен инженер в SumUp. Тук е доста яко. Можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
Hey there, everybody. Thanks for tuning in today. I'm James Daniels, an engineer on the Firebase team. I am joined by Minko, a colleague on the Angular team.
Hello, everyone. My name is Minko Getchev. I'm a developer programs engineer on the Angular team at Google. Today, we're going to develop an application with Angular and Firebase. In general, we're going to build a Kanban board with different tasks that we can move across 3 different states. We can move them from a backlog to in progress and finally to completed.
Now, before we jump in, let's talk a little bit about the technologies we're using and the tools that can make your job easier. First and foremost, we're building a web application, so we need a place to host it. That's where the aptly named Firebase Hosting comes in. Firebase Hosting is a great product for storing static web assets. It puts everything behind a CDN, provides us with an SSL certificate, and we can even point our own domain at it once we're ready to go live to the world. Next, we need a database. This is where Firestore comes in. Cloud Firestore is a highly scalable NoSQL database that has client-side SDKs, allowing us to write directly from our web application code, securely, without the need to spin up API servers. Further, the SDK itself allows you to keep your client state in sync with the server using real-time listeners. This significantly cuts down on the complexity of building a modern reactive interface. Now, let's spend a moment on tooling. We have a few options that'll influence our choices. The Firebase CLI is an NPM module that gives us the ability to push files to Firebase hosting, deploy cloud functions, security rules, and more via an easy-to-use command line interface. This is how many of our developers choose to interact with the hosting products. Next, there are web development frameworks that provide their own CLI experience and have hooks that allow developers to integrate with them. Notable examples here include Angular and Ember.js, whose CLIs can become Firebase aware using SDKs built by the Firebase team. The Emberfire library, for instance, makes a connection between the Firebase CLI and Ember, allowing developers to build and deploy their app with a tooling that they're already familiar with. Next, we have the Firebase Hosting API, a REST API that enables programmatic deployments to Firebase hosting. While admittedly a bit more manual, it gives you complete control over your release pipeline and can be consumed in environments that aren't running Node.js or don't have existing command line interfaces. There's some great integrations here too. Glitch and StackBlitz, for instance, both have deploy to Firebase capabilities built on top of this API. That's the high level on the tooling options available to us right now. Perhaps there's an integration you'd like to see, but doesn't exist today, whether it be your favorite build toolchain, editor, continuous deployment pipeline. And hey, maybe you'll be the one to build it. Now that we've talked a bit about the technology choices available to us here, I'm eager to start building our app. Let's jump over to Minko, who will get us going.
So with Angular and Firebase, we're going to build this Kanban board. First, we're going to create a new Angular CLI project. For the purpose, to build the actual user interface of the app, we're going to add Angular material and the Angular CDK. Right after that, we're going to develop our application's features. And finally, we're going to just add the Angular Fire package to our Angular CLI workspace so that we can introduce some real-time capabilities and deploy our application to Firebase hosting. First things first, let us create a new Angular CLI workspace. For the purpose, use the ng-new command specifying a project name. We will not need the Angular router, and here we're going to use just CSS. This command will scaffold the project and install all of its dependencies. As a next step, let us add Angular material. Installing the package with npm will not do the entire trick, so we're going to use the ng-add command instead. It will not only install Angular material, but also trigger the ng-add schematics, which will integrate the module with our application. First, by allowing us to select a theme and adding the associated styles to the project. It will also add a global material typography and import the browser module in the app module. And all of this is going to happen just auto-magically. Notice that the ng-add command added the Angular CDK to package.json as well, since it is a dependency of Angular material. Now let us quickly develop the layout of the application. We'll first open the app component HTML and delete its entire content. At the top of the template, we'll need to add a math toolbar. Inside the toolbar, let us add a local Fire department icon, and next to it, set the title of the app, which is Kanban Fire. When we go back to the console, run ngserve, and well, here we're going to see just a bunch of errors. This happened because we forgot to import the components that we're actually using from Angular material in our application. Now let's do that. We'll first import math toolbar module from the Angular material toolbar module. Next, we'll add it to the list of imports in app module. We'll do the exact same thing for math icon module. Finally, let us set the color of the toolbar to the primary color of our theme. We can now preview what we just did. As a next step, let us add 3 columns or swim lanes representing the different states a task could be in. In the template of the app component, we'll create a column for the backlog. The backlog will be a material card, and inside of it, we're going to show the individual items from our to-do array by using the ng4 directive. We'll do the exact same thing for the progress and the done columns. We should now improve the layout of the application. First, we'll wrap the column in a container wrapper. And next, we will add a list class to the individual columns. Finally, just add item class to the cards showing the individual tasks. In the styles of the app component, we'll use Flexbox in the container wrapper and set its margin top to 20 pixels. Each column will have 400 pixel width, margin right 25 pixel, and a solid gray border with 1 pixel width, and of course, a minimum height of 60 pixels. Yep, that just looks fine now. Items will have margin bottom 10 pixels, a cursor pointer, and box sizing border box to make sure that their sizes do not change when we start dragging the individual tasks. Oh, see, now we're getting another set of errors in the console because we are missing an import. Let us quickly add the math card module to the app module. We also need to declare the to-do, in progress, and done arrays in the app component. Let us also add a few items to the to-do array. And here we are. Now we see 3 lists and we have items in the first one of them. To implement the drag and drop functionality, all we need to do is just to use a couple of directives from the drag drop module in the Angular CDK. Let us import it in the app module. After that, we'll need to update the cards representing the individual columns. First, add CDK drag to the math card representing the task, and to each one of the columns, we'll add the CDK drop list directive. After that, we'll handle the CDK drop list dropped event by invoking drop method passing the object. Next, we'll set their CDK drop list data to the founding array from the app component. And now let us format the template with prettier. After that, we'll reference each drop list using a template variable. We'll use backlog list for the list of to-do items, in progress list for the list of in progress tasks, and done list for the list of completed tasks. Finally, we'll connect each drop list with the other two so that we can transfer tasks between them. Let us implement the drop method in the app component. The event object is of type CDK drag drop. It contains the previous and the current containers. We'll need to handle 2 cases here: reordering tasks in the current column and moving tasks across different columns. If the user is reordering tasks, we'll use the move items in array function coming from the CDK, passing the container data, previous index, and the current index. Alternatively, we want to use the transfer array item by passing the data from the previous container, the data from the current container, the previous index, and the current index of the task. Now let us try the drag and drop functionality. Notice that there is a weird effect here. When we start dragging a particular item, we temporarily create a clone of it. To fix this, we'll need to go to the app component CSS and declare the class CDK drag placeholder. Angular will apply it to the placeholder when we start dragging. To hide it, we'll just set its opacity to 0. To improve the drop effect, we'll just add 250 milliseconds transition to the CDK drag animating class. The only missing feature now, before we go to the Firebase portion of this talk, is to implement the functionality for adding new tasks. For the purpose, let us wrap the container wrapper into another div element which will contain all the 3 different columns, plus form for adding new tasks. Let us use the content wrapper class for this div and add a few styles for it. In the app component CSS, make its width 1000 pixels and set its margin to auto so that we can center it. In the app component template, add a mat form field label inside of it with a value task name and an input with the mat input directive on it, which handles enter key down events, just invoking the add item method. Don't forget to import mat input module in your app module to make sure that we have all the directives available. Inside the add item method in the app components controller, we just want to get the target HTML input element, push its value to the to-do list, and reset it. Now we can add new items to our to-do list. So that was pretty much everything on the Angular side. Now James can show you how to add Firestore and deploy the application to Firebase hosting.
Thanks for getting us rolling, Minko. Well, to get Firebase in here, the first thing that we're going to want to do is add the Angular Fire library. So we'll just do ng add Angular Fire. This will actually install the Firebase packages, Firebase tools, everything that we need to put in real-time capabilities and deploy to Firebase hosting. So I'll link this to the project that I created for this. Now that we've added Angular Fire, let's pull in the modules we need. We'll first start with Angular Fire, and then we'll pull in the Angular Fire Store module. We'll initialize Angular Fire with our application's web app settings. You can get those from the Firebase console. Next, in our app component, let's actually inject Angular Fire Store. Then we can convert our task list to a Firestore collection. So we'll go ahead and get the collection to do. Then we'll grab the value changes from that. What that'll do is actually create an RxJS observable of the values in Firestore. And this will be a real-time connection. ID field will go ahead and populate the item's ID into the task. We'll do the same for in progress and done. Now with that, let's go ahead and work on our new task. So instead of pushing to an array, we're actually going to grab our Firestore collection and we're going to add to it. Now edit. So here, when we're deleting, we're actually going to want to, again, jump into that Firestore collection, grab the document ID, and then delete it. Otherwise, let's update it. And then we can get rid of all this. Finally, the drag and drop. So here we're actually going to want to do a transaction, right? This works in two pieces. So we'll go ahead and create a Firestore transaction. That'll take a promise. And in the promise, we're first going to delete the item from the prior collection, and then we're going to add it to the next collection. Now, finally, our data is actually observables now. So we're going to want to change our template code a bit. So we're going to want to point our CDK drop list data to the async. We're going to want to update that for the empty list check as well as the ng4. With that done, let's bring it up in the browser. We can do side by side here now that we're persisting in Firestore. I'm happy with this, so I'm going to go ahead and deploy it to Firebase hosting. I can just call ng deploy since we added Angular Fire. This will actually use a schematic, reach into the Firebase tools, and build and deploy our site on hosting for us in one simple step. And we're live.
If you're building tools for developers or just frameworks, and you want to enable such path for your favorite framework, just like what we showed today with the Angular CLI and the Firebase schematics, just take a look at them. They're at github.com/angular/angularfire. You can develop a similar mechanics for your favorite technology so that you can enable developers to add real-time capabilities with Firestore and automated deployments to Firebase hosting.
Thanks for joining us today. We were happy to demonstrate some of the new capabilities of Firebase hosting and our integration with the Angular CLI. If you'd like to dive a bit deeper in today's exercise, be sure to catch the code lab that Minko has developed for the summit. Links to this and more can be found in the description below. If you like this video, be sure to subscribe to the Firebase channel And make sure to catch the other great talks coming out of the Firebase Summit.
Thank you for watching and happy coding. See you next time.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I could see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, where the light ain't allowed to go. When the line gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth manager. He advanced financial technology.
Alright, what if I set the parameters to look for equities in the energy sector? And here, alert set.
We'll trust DevExpert Solutions trading decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to friends.
DevExa, Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize ideas in real time. But most importantly, Dev Expert systems help Ted act ahead of editors.
So, what?
I think we need to react fast. Devexa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. Dev Experts will be there.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте! Аз съм Симеон и съм софтуерен инженер в SANAP. Тук е доста яко. Можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
Hello, everyone. My name is Minku Getchev at Google, and today in this presentation, I would want to share with you what is the current state of Angular. So in this talk, we're going to go and cover two main topics. First of all, we're going to stop on some of the strengths of the framework and how organizationally and structurally Google helps us to support probably the most essential and unique of them, called evergreenness. At the second part of the talk, we're going to focus on what Angular has been up to, what you can be expecting from version 11, and where are we heading. So let's get started. First, I noticed that while working on this content, everything was pretty much spinning around three main core topics, and these are in fact our core values for the team. We want to develop a technology that allows developers to create applications that their users love to use. At the same time, we want to make sure that we bet on development experience, and folks have fast change refresh cycles. We want to ensure that they're having the entire tool set that they need, and on top of that, that everything integrates really well together. It's interesting to notice that sometimes what is great for developers and development experience sometimes has impact on the experience of end users. For example, makes applications slightly slower, and vice versa. Sometimes what makes applications really fast and great for the end users has implications on development experience. So it is really interesting to balance between these two. Also, a lot of folks from the team are coming from the open source community, and we really value that everyone in our community should feel welcome and their opinion should be valued. I have been part of the Angular community about 5 years before joining the team, and well, I know how important such an inclusive environment is. So our core strengths, and let us focus on the specific one of them that I mentioned already. So first, when I'm talking to developers, they're frequently mentioning that one of probably most noticeable Angular strengths is its opinionation. Angular comes with the batteries included, with the best practices from the beginning, such as statically typed language that you can use, type-checked templates. We're coming up with dependency injection, with well-integrated tooling with our style guides, and much more. This allows folks to scale. They can start in a small project and later on grow it to hundreds of thousands of lines of code. And at the same time, with the scaling of their source code, they can scale their team as well. And everyone they hire is going to be already familiar with the basic structure of an Angular application, since we are opinionated and we have a single way of doing things. This way, your project and your team are going to scale well. Another unique strength that we're probably not talking about enough is the evergreenness of the framework. This means that you can stay up to date with the latest changes that Angular introduces. And we have this concept of feature drops that we share as part of each next release, and you can take advantage of these changes just by running ng update. I'm going to talk much more about this and how are we achieving this, thanks to our organizational structure in a little bit. But clearly, we also have this fantastic ecosystem. I know that because, well, I was building some of these tools before joining the team, right? I know it doesn't sound too modest, but I was really enjoying building tools for static code analysis in my spare time before. And I see all the fantastic folks in the community right now building development tooling, different state management, libraries, and components for Angular. So Angular wouldn't be what it is today without the rich ecosystem. Now let us focus on the evergreenness of Angular. We have this saying inside of Google that, well, the only constant in our organization is change. And I really didn't understand what exactly this means until I went through several different reorganizations. I started, I believe, originally under Google Ads, and I moved to a few different organizations, and Google was doing that so that our communication can be more efficient. Our work processes could be more efficient, and we can work together in a healthier and faster, more productive environment. At a certain point, things were changing so quickly that for celebration of one of these reorganizations, I got this chocolate candy. And a couple of weeks ago, a couple of weeks after that, when I was already in a different organization, I found this candy that I wasn't able to eat before we kind of changed the org and moved to a new one. So, well, this can speak a lot to you about like how rapid changes are happening inside Google and how much we value productivity and efficient communication. Angular is in general an infrastructural team. So we're building infrastructure for development of web applications. We have a couple of, but we're not building something like, let's say, Gmail or Photos. We're building tools that developers can use to develop such products. And currently, we're in a such infrastructural organization. We're in the so-called core systems. Core systems is a functional structure, functional organization which incorporates most of the infrastructure teams inside of Google. Originally, we had different like product-based structure where each individual product area, such let's say Google Social, Google Ads, and so on and so forth, they had their own infrastructural teams. But since then, things changed a little bit because there was duplication of the individual efforts and the infrastructural teams weren't able to collaborate closely together. Since then, now we're in core systems with a bunch of other fantastic technologies that you have probably heard of. We're in fact very closely collaborating with TensorFlow and Firebase and all other such developer productivity tools inside of the organization so that we can come up with plans for a smarter and more efficient future of the web development. Under core, we have another sub-organization called Core Web. This is the infrastructure for development of web applications inside of Google. There we have foundations where you can find the TypeScript, JavaScript team, and frameworks where you can find Angular and Wiz, which are two of the most popular frameworks inside of Google. Together with Wiz, we really frequently brainstorm how we can improve the performance for end users. And we have different trade-offs of these technologies. So we're constantly trying to inspire each other so that we can grow together faster. You may notice also the TypeScript JavaScript team. You probably know that TypeScript is developed by Microsoft, but we have a single team inside of Google that owns the TypeScript compiler for all the projects in the entire company. They make sure that everyone is using the last version of TypeScript. And in fact, previously, the TypeScript team was part of the Angular team, since Angular introduced the language as the best practice in Google. Something interesting to notice is that as the Angular team, we're not only building Angular, but we also support all the projects using the framework. And in fact, we can notice some of this mindset. For instance, when we're shipping Ivy, to ensure that we are supporting all the existing projects out there, we built an external monorepo with the most popular, I believe, about 200 libraries that are using Angular. We want to make sure that all these libraries are functioning with Ivy, and we built a CI that was checking whether each one of these libraries works with the latest version of Angular after every push to our monorepo. So this mindset is really helpful, but let me tell you how many projects we in fact have to support. Angular has been around for about 4 years. We celebrated our birthday a few weeks ago, and I was in fact on this release party that Angular had on the 14th of September 2016. That was just a couple of weeks after I moved from Bulgaria to the Bay Area. I wasn't working on Angular back then. I was working on my startup, but I was contributing a lot to the framework. But anyway, that was about 4 years ago. Since then, inside of Google, we have over 2,600 Angular projects. And this is a significant growth since last year. On top of that, there are hundreds of thousands of TypeScript files. Really, hundreds of thousands. I kind of counted them with our internal code search. And as the Angular team, we need to make sure that all these 2,600 applications out there are functioning with the latest version of Angular. Well, this is not an easy task. And the way we're doing it is thanks to our internal monorepo. Clearly, this has a lot of implications on how are we taking care of the backward compatibility in the open source community as well. but I'm going to reach that stage. Just bear with me for a little bit. The only way we can support these 2,600 projects is thanks to the way we organize source code inside of Google. We have this monorepo where we know exactly which are the dependencies of Angular, and when we update the framework, our build system compiles all these projects in our internal CI and verifies for which of these projects the CI passes and for which one of them some tests fail. So if we break something, this means that we're going to know about it like immediately, even before we release the next of Angular, because every time when we push code to GitHub, we're syncing this code to our internal monorepo, and we are running all these hundreds of thousands of tests. This guarantees us a lot of things, but first of all, huge stability. Well, we have quite a few tests on Angular. If you look at any of our repositories on GitHub, you're going to see that we have a pretty decent test coverage. But we cannot guarantee the complete test coverage that we're getting out of these hundreds of applications that are using the framework. Some of them are a couple of hundreds of lines of code. Others, such as Google Cloud Console, are a couple millions of lines of code. You can imagine that they're using every single piece of the framework that we have to offer. And if we break something, we are going to know about it. It is really hard to achieve such test coverage. I have been talking to some friends of mine who are working on the Linux kernel. And, well, it is a common pattern there. You just push a patch to the Linux kernel. But at the same time, this may break someone's smart fridge because they don't have this enormous test coverage of the Linux kernel. And this is something that they have kernelci.org, which is trying to achieve what we already have for Angular for free. Of course, at the same time, we sometimes want to break Angular, right? We want to innovate. But if we break Angular, we need to fix all these 2,600 projects in Google. And clearly, we want to fix everyone externally using Angular. We want to migrate everyone to the latest version of the changes we introduced. We clearly want everyone to take advantage of the best and the greatest features that we introduce as part of the framework. We do that by using automation. We create small TypeScript programs that are transforming people's projects and migrating them to the latest version of Angular. You have seen this as part of ng update. And, well, finally, we see a lot of innovation. We see how the individual projects are using Angular, and this is really helpful for us to define best practices and integrate them as part of our core tooling. But my guess, the biggest strength out of this is the evergreenness of Angular. We ensure that you have these feature drops, that every time when we push new features to the framework, you can take advantage of them just by running ng updates, Angular CLI, Angular Core. This is, in my opinion, very unique, since in most of the projects I've been working on, we usually have some fixed version of the framework and our tooling, and that's what we use for the next years. Right, well, I hope that I was able to excite you about the evergreenness and how important it is. In fact, some folks have even optimized it to such extent that it is part of their continuous integration. Every time when their CI runs, they check for new versions of Angular, and if there is one, they're automatically running ng update and opening pull requests to their repository, migrating everyone to the latest version of the framework, and merging this pull request automatically if their tests are passing. So that is what evergreen means. And well, that is why I think it is so much important and a unique strength of Angular that is really hard to achieve otherwise. Now, let me tell you how are we trying to make Angular successful. Our main stakeholders of the framework are clearly developers and the users of the web. As I mentioned, sometimes the requirements of developers are slightly different compared to what we need to achieve in order to make the experience of the web as good as possible. And at the same time, we have quite a few stakeholders. Only the Angular language service has over 1,700,000 installs. That's a lot of installs. So you can imagine that we're getting a lot of different requirements in different forms. We're getting requirements in terms of GitHub issues, customer feature requests when talking to folk on conferences. We're running our internal and external surveys to see what people like about Angular and what we could improve. Well, we are a large framework. We have a lot of source code and a large API surface. We want to innovate and change things. So we can imagine that we have also a decent amount of technical debt that we need to deal with. At the same time, we have a lot of GDEs with a lot of great ideas. We do customer interviews and so much more. So we get thousands of feature requests in different forms. And the interesting thing is that the requirements of users are not really well represented all the time. Here, for example, we're getting most of our feature requests from advanced developers who are more vocal in our community. So we need to think about the folks getting started with Angular as well. What we usually do in order to prioritize all these hundreds or thousands of requests is to look at our values. We're thinking how we can implement a certain feature in a way that is going to make the users of the web happy. We're thinking about how we can develop this feature in a way that it improves the development experience. And finally, we're thinking about how we can make it in an inclusive way, where everyone would feel welcome. Clearly, sometimes we're doing better than others, and there is always clearly place for it, and we're working on this. If we find an intersection between all these 3 points, this usually means that this feature is a great fit, and we can go ahead and implement it. Now, we have been sharing, we worked very heavily on one of our projects called Ivy. We shipped it earlier this year, in February. This project has been pretty much a rewrite of the internals of the framework in terms of runtime and also compiler. Well, it was also impossible to ship this change without having this internal mono repository where we were able to verify that things work. Also, by having this external monorepo with all the external libraries, where we were checking some of the only external toolset that we have been developing for engineers. In the meantime, while we were developing Ivy, which took probably about 2-3 years in order to verify that everyone can take advantage of the latest features without breaking many projects, we actually collected a lot of technical debt. Our main focus was Ivy, and we weren't able to pay too much attention on other requests because we wanted to ship Ivy, make it available, and let it enable many future improvements that would be coming up and will be rolling out in the next years. So, well, what you could expect from version 11 is pretty much dealing with some of this technical debt, improving the performance of Angular, and a few more things that I'm going to share with you just in a second. We have this internal code name for an operation bylock. Bylock is an operation where we spend up to 70% of our time in triaging issues on GitHub. So far, we went through hundreds of different issues. And at the same time, we reduced the number of issues in the Angular CLI with 30%. We have fewer than 15 or even 10 issues under components, and we were able to resolve some of the most wanted feature requests and bug reports. Let me share a couple of them. So we fixed this issue around lazy loaded module in named outlet that throws an error. We're able to resolve other issues in the router as well, and some improvements in forms. At the same time, we resolved the third most highly voted feature request on GitHub, which is around using translation strings outside of Angular templates. I'm particularly excited about this one because our internationalization pipeline is very highly optimized for allowing developers to ship great experiences for their users. We have taken some trade-offs, for example, adding some extra build time, in order to make sure that our internationalization pipeline produces applications with zero runtime overheads. We're inlining translation strings, and this way we're also producing smaller bundles because of your instructions and also better tree shaking of the translation files. You can learn much more about this effort in this fantastic blog post coming from Pete Bacon-Darwin from the Angular framework team. In this blog post, Pete talks about some of the improvements that we did in terms of feature set, and also how we reduced the build time and made it a couple of times faster, thanks to the new way we are going through our internationalization pipeline. Something that I've never heard of is that people are really satisfied with their build performance. Of course, we all know that builds have their own place in our development flow. Builds are helping with catching some frequent errors by using the build system of the language, or in this case, the template type checking that Angular provides. Builds are also great for optimizing our assets so that we can deploy them to production and be in their smallest shape possible. But at the same time, builds could be annoying. They could be taking time. So we are constantly working on making the Angular compilation pipeline faster. Some of the improvements that we did were in ngCC. So you could be expecting 2 to 4 times faster compilation with our compatibility compiler. Yost from the Angular compiler team, he kept doing different profilings so that we can figure out how we can improve the performance a little bit more at batch releases. We shipped a few additional improvements in the Angular compilation pipeline. So make sure that you're keeping up to date to take advantage of them. At the same time, we noticed that in order to improve the Angular, we can actually upstream a performance improvement in the TypeScript compiler as well. So in this pull request here, Yost introduced an improvement in the performance of the TypeScript compilation pipeline that the Microsoft team is going to release probably in version 4.1 of the language. All right, so you're going to get faster builds, but what better than hot module reloading? Since with hot module reloading, we can have faster development cycles. You don't need to reload the page on each change. Instead, you can get all the changes pushed directly from your development server to the browser. Hot module reloading has been possible in Angular for a while now, but with the latest improvements that we're going to ship as part of version 11, you can now use just the HMR flag as part of the ngServe experience and, well, get this feature for free without having to configure anything. A couple of other things, which are even larger in terms of effort, but that we're going to roll out more and you're going to see benefits of in the future even more, are our Ivy language service preview. We made our language service more useful by stepping on top of the Ivy compiler, and we'll be rolling out this change in the next couple of months, slowly, incrementally. But in version 11, we'll be able to take advantage of its very early preview. At the same time, we're working closely with the Webpack team. I'm talking to Tobias from the Webpack team probably at least once every 6 months so that we can talk, we can discuss how we can provide fast experience and how we can migrate developers to the latest version of the builds tool. As part of version 11, we'll be shipping a Webpack version 5 preview that is going to allow you to give a try to the latest and greatest tooling that the Webpack team created. We will be slowly rolling out some of the improvements that Webpack version 5 is introduced. For example, more efficient tree shaking, faster builds thanks to disk persistent caching, and eventually also module federation. But in version 11, you could be expecting just to have an opt-in preview of Webpack 5. We have been also working very closely with the ESLint community, and in particular with James Henry, who implemented a really good migration path of existing TSLint projects using TSLint for linting, to ESLint. This is a community effort entirely. So on the Angular team, we have been just providing some guidelines on how we can make this more efficient for Angular users. But the entire effort and the entire migration path has been really well defined by the community. So as part of version 11, you're going to have a path forward to migrate from the deprecated TSLint to ESLint. And as I already mentioned, we have plenty of bug fixes and improvements that we will be rolling out. So what's coming up next? What is coming up in Q4 and 2021? One of the improvements that doesn't seem huge at first, but is going to bring a lot of performance gains is the elimination of render blocking resources. When you have an index.html file and when you're referencing styles inside of it, the browser cannot start rendering your content until it downloads all the styles preceding this content. In order to fix this issue, we have been working very closely with the Chrome team. We have our weekly syncs where we're talking about how we can make web better. So in our syncs, we discussed different strategies for removing these render blocking resources. We stopped on a strategy where we'll be statically analyzing all the styles in your CSS with the content of the page, and we'll be inlining the critical CSS as part of the build process. From there on, we'll be able to take the rest of the styles and load them lazily. With some very early benchmarks, we noticed 3.7 seconds improvements in first contentful paint. So this is an improvement that I'm pretty excited. And the cool thing is that, well, since Angular is evergreen, you'll be able to take advantage of this for all your existing projects just by running ng updates. Some other larger efforts that we have been focused on are Webpack 5 and thinking about how it can enable micro frontends. It has this concept of module federation, which could be the solution. Still, we cannot commit to a particular timeline, but this is something that we're really interested in and investigating right now. Angular DevTools is another effort that I'm going to talk about in a little bit. We also have this mindset that we should simplify the learning journey for Angular. And the easiest way to do that is by using the conceptual overhead. Making ng modules optional is going to enable folks to get started with Angular simpler. And this is something that we have been thinking about for a while. So this is an effort that we'll be tackling in the future. Also, zoneless. This is, again, a project that I'm going to mention in a little bit, and we're going to dig in a little bit more details. But before that, DevTools. You probably know about the Chrome DevTools extension, Augury. It was developed by Rango.io, and it shows you your component structure. It also previews the relationship across the individual injectors for your Angular application. You can also see the relationship across different routes and so on and so forth. So because of the great domain expertise that the team at Rango has, we partnered together to develop Angular DevTools. We are still prototyping DevTools, so I cannot give you a specific timeline for its release, but I would want to share a couple of features that we're planning to introduce. Of course, we're going to have the same component explorer that would allow you to preview the state of the individual components, update it, and reflect the changes in the view. On top of that, however, we have been working on a profiling tab where you can preview the individual change detection cycles. You can see what triggered a particular change detection. You will be able to see how much time you spent in change detection and also in lifecycle hook execution, individual components, and much more. So that was it about DevTools. I hope you'd enjoy using it at least as much as I do. Now let me spend some time talking about zoneless. In 2019 on Angular Connect, Miško gave this great talk talking about how we are making Angular fast. There, Miško discussed a lot of low-level virtual machine optimizations that we're taking advantage of. He discussed the low memory footprints that Angular has, which is great for any device out there. It doesn't matter whether we're building web applications for smart TVs, for smartphones, or for powerful desktops. We have fast iteration on top of the entire component tree, and we're updating only the bindings that has actually changed. Well, although we have this really fast change detection mechanism, at the same time, we do not provide too fine-grained control over it to developers. So this time, we end up with a lot of redundant change detection cycles triggered by Zone.js. With the zoneless effort, this is one of the problems that we're planning to solve. Zoneless is still in a very early planning stage, so we have more details. We'll make sure that we share them with you so that we can make the decisions together. Finally, I wanted us to talk more on the steps we're taking to make the Angular community even more welcoming and open. One of the main questions from folks that we have heard was that they don't know where Angular is heading. So we work hard to incorporate all the work that we have been tackling and all our future efforts that we're currently planning to work on in the Angular roadmap. This has been actually much harder work to do than you can probably imagine because the web is changing really fast. And at the same time, we are trying to prioritize a lot of features from different sources. So, well, we finally were able to do that and we shared it on Angular IO. We'll be updating the roadmap quarterly, so make sure you stay up to date by checking it out. The next effort we did was in order to build a more inclusive development process. We opened 2 pilot RFCs to discuss a couple of major efforts. We got a lot of great feedback, which helped us to shape the decision on how are we going to ship Ivy libraries, and also how are we going to eliminate render blocking resources with the Angular CLI. Well, I hope I was able to show you how we are structuring our work around our 3 core values. A couple of just small examples are around how are we helping developers to ship applications that their users love to use. For example, our internationalization pipeline is entirely focused on end user experience. We're also constantly trying to make the framework faster and ship applications in the most optimized way, collaborating with different teams inside of Google. Second of all, we're really focused on development experience. Well, we're developers ourselves, and we know what is the pain of waiting for a slow build to complete. That is why we're doing constant iterations on top of the compilation pipeline that we maintain, and we are enabling features such as hot module reloading. And finally, community. This is one of the most essential parts of the Angular ecosystem. We want to build Angular together where everyone feels welcome. Thank you very much for your time today, and thank you very much for listening to my talk. If you have any questions, feel free to reach out to me on Twitter at mgetchev. Thank you very much again, and until next time, happy coding.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте, аз съм Симеон и съм софтуерен инженер в SumUp. Тук е доста яко, можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, в супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I can see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster comes out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth manager. He uses the most advanced financial technology.
All right. What if I set the parameters to look for equities in the energy sector? And here, alert set.
William trusts DevExpert solutions to help him with his trading decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to his friends.
Devexa, show me Earth Petroleum Inc.
Okay, that is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize his ideas in real time. But most importantly, expert systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to act fast. Devexa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. Dev experts there.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте! Аз съм Симеон и съм софтуерен инженер в SumUp. Тук е доста яко, можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, в супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I can see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, where the light ain't allowed to go. When the line gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth. He uses the most advanced financial technology.
All right. Set the parameters to look for equities in the energy sector. Right here. Alert set.
William trusts DevExpert solutions to help him with his trading decisions because they react to market movements faster than a human. He talks to Smart same way he talks to his friends.
DevExa, show me Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted.
Innovative technology helps him visualize his ideas in real time. But most importantly, DevExpert system help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. DevExa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. Dev experts will there.
Well, hello there. Welcome to JSTalks 2020. My name is Christo from Chaos Group, and I'm happy that you will be joining my session today, which is called Creating gRPC Web Applications. Thanks for joining actually this great event. It's taking place for another year. I think it's the 6th or 7th year in a row so far, and I would say that this is one of the biggest and greatest JavaScript conferences even on the Balkans. And I'm happy that it's taking place in Sofia, Bulgaria. Today I'm going to show you a technology for API design called gRPC, or more specifically gRPC for web. And long story short, with this framework you can design your APIs and consume them from the browser with ease, and not only from the browser but from any other service or application. Before we dive into, let me give you a quick overview of myself. I've been working in the field of web technologies for 17 years already, mostly dealing with front-end technologies, but I've enough experience in the backend too. But anyway, my most experience involves JavaScript, both browsers and Node.js. I am also a lecturer, and yeah, I love JavaScript. I love teaching people JavaScript, and I'm leading one of the integrations team at Chaos Group. Okay, let's get this started. I'm now going to share my screen, and there we go. Before we dive into today's session, I would like to first walk you through the agenda. So first, I'm going to cover what is gRPC Web. Why do we need it? I'm going to have a look at some cons and pros. Yeah, first the cons, after that the pros. I'm going to show you a demo, and the demo is desktop application with web interface for system notifications. And finally, I'm going to give you some tips and takeaways. So let's get this started. Before that, thanks to our sponsors. Without all of these huge and great companies, most probably this event won't happen. Thank you all. And let's now have a look what gRPC for web is. Before that, we'd better first clarify what is gRPC, or even better, what is an RPC. So what is an RPC? RPC is abbreviature, and it stands for Remote Procedure Call. And it can be simply explained by calling a procedure or subroutine from one machine to another remotely via a protocol, of course. RPC is really old and mature technology, which is dating from the early 80s. And it's based on the request response protocol. gRPC, on the other hand, is quite recent technology. It's 4 years old, started 2016. It's, of course, RPC framework. It's developed and maintained by Google. It's using HTTP2 and is very, very preferred for communication between microservices because it's very fast and efficient, and mainly because it's language agnostic. So you can have many microservices written in different languages or platforms, and you can communicate between them very easily by using gRPC. I think 2 years ago, gRPC for web was announced, and thanks to it, the browsers now can use gRPC and can make gRPC calls to services. So why do we need gRPC web, and how does it helps us, and what problems does it solve? First of all, I would say that if someone is asking me, okay, why are you using gRPC or not REST, for example, or even GraphQL? And the answer is that it's usually, or it has to be, a matter of API design. So if you simply have to deal with some resources, you have to do some CRUD operations with them, then it's totally fine if you go with REST. If you want to develop an API for multiple clients, that and you have to support multiple versions, and you have to be backward compatible, and your data changes in time, then most probably GraphQL is your best friend. If you have to call a procedure on a server from the browser, then most probably it has to be RPC. But gRPC and gRPC web in private is not the wisest choice for only this. It also supports streaming API, which allows the client to listen for events over from the service. One of the biggest pluses of gRPC is that it implements the interface definition language called protobuffers, which is, I would say, very easy to use, very easy to learn, with which you can easily design your APIs, all the namespaces, all the API calls, all the requests and responses parameters. And the greatest thing is that the toolset around gRPC auto-generates all the stubs for both client and server. This is great because this saves the developer time, and it integrates very well with most of the editors' IntelliSense, which still improves the time of developing applications and writing code. Let's have a look at some pros and cons, or as I said, cons and pros. If you want to dive into gRPC and gRPC web particularly, you will have most probably some hard times because documentation is really poor at the moment, or I would say at the moment we first started researching this technology at Chaos Group, which was in the beginning of this interesting year. And it was very hard to find out how exactly you need to set up your environment in order to run gRPC calls in the browser. As I said, the setup was not trivial at all, not only for the poor documentation, but because of the tool set around gRPC. We had hard times to find the right configuration for JavaScript that creates the stubs for us, the right stubs for us. Thankfully, there are some external tools which makes our lives easier. For example, Uber have open sourced a project called ProtoTool, which makes the generation of the stubs very easy. And yeah, if you once set it up, this whole architecture pays off later. Another con is that gRPC for web requires the so-called envoy proxy. And the reason for that is the fact that gRPC is built on top of HTTP2, and it uses the so-called trailers, which are not interpreted by the browser. So basically, the browser uses the HTTP headers and body, but not the trailers. And gRPC extremely counts on the trailers. So that's why that's where this envoy proxy comes in. It has to convert the trailers into a format to serialize the information from them into the body of the HTTP request, so the browser understands it, and vice versa. When the browser sends request to convert the appropriate information to HTTP trailers. Setting up this proxy again overcomplicates the setup, but thankfully for Golang specifically, there is one solution by the guys from Improbable Engineering, and it's in-memory Go proxy, which do not require you to set up that envoy proxy. And this in-memory Go proxy takes all the heavy lifting of this communication between the browser and your service. And yeah, you simply need to add this as a Go dependency. It will work. So it simplifies the setup a lot. But yeah, that's a private case for Golang. If your service is in Go, then your life is easier. But I'm pretty sure that there are alternatives for other languages too. Let's have a look at the pros now. So with gRPC and gRPC Web, you can design your API in a language agnostic way. It allows you to structure your data. It supports versioning. One of the greatest parts, as I already said, is the auto-generated stubs. I'm going to show them in the demo, so you see how cool it is to have this for you already generated. Auto-generated code is awful, but we don't have to deal with it. We simply import its exports, and we create our API. And yes, speaking about the JavaScript stubs, the code and the interface is pretty much Javish, I would say. Simply because, at least for me, this is not the natural way how you would write a JavaScript function or application or request or routine or whatever. But yeah, we'll get to that during the demo. And last but not least, that's the streaming KPI, which is a great plus of gRPC. Okay, and now it's time for the demo. As I said, I'm going to create a desktop service for showing OS notifications as reminders or whatever you may need them. The project is hosted at GitHub. There is a link in this presentation on that slide, as you can see. So yeah, once all the presentations are shared with you, you can have a look. And let me show you the first screen. Yeah, let me start the service. Okay, so I built the service, and now it starts listening to HTTP2 on port 4333. And yeah, that's the very first version of this application. As you see, I'm opening in the browser in Google Chrome. The UI is React application bootstrapped with Create React app. The UI is from Semantic UI, and yeah, basically this application should be able to schedule and list scheduled notifications that will pop up as a system notification, and yeah, display the title and the message that you would set them to. Right now, this is the very first version. As I said, there's only the title and the message fields and a preview button, which should show me an instant preview of the notification, how it will look. Of course, it does not work yet because I haven't implemented that in the UI. So that's what I'm going to do right now. So let's get to the implementation. The project is organized in 3 main directories: the API, the service, that's the Go service that is listening for gRPC calls and talking to the operating system showing the notifications, and the UI part, which is JavaScript React application served by the service, and displaying UI for listing and scheduling these notifications. Okay, let's first have a look at the API. As you can see, there are two directories in it. The gen folder, in which are my auto-generated stubs, and the proto directory, which is more interesting. Here I keep all the proto definitions. As I said, gRPC implements interface definition language called protobuf, and here is how a protobuffer looks like. This is our syntax, the version of the protobuf we are using. We're using version 3. We define our package. This is the name of our API. It's notifier version 1. And we describe our services, which are actually our RPCs, or procedures that will be called remotely. The namespace is notifier API, and our first RPC is called show notification. It accepts show notification request and returns show notification response. In the show notification request, we accept a title, which is a string, and a message, which is also a string. And the show notification response is empty because it does not return anything. We are simply calling this show notification RPC, and we expect our Go service to call the operating system and display that notification with the title and message we are passing as parameters. This is exactly the RPC which I'm going to call here in the UI by clicking this preview button. But before the coding, let's first have a look at how to get there, because we are not there yet. There are a couple of things we still have to do. So as you can see, this language can be interpreted by the browser, by the client in that look. So we need to generate our JavaScript stubs from it. And for that purpose, I'm using the Uber's Pro tool, which is a great tool for generating stubs, generating gRPC stubs. It's great because it supports a very easy configuration. It can be configured very easily. And yeah, it reduces the pain around creating stubs using the built-in, the native tool set around gRPC. Let's have a look at one configuration for this proto tool, how it looks like. So it's a YAML file. Basically, what is more important for us is the generate part, the options and the plugins we need. So here are some options for Golang, defining the import path. Also, what plugins we are using. We'll be needing the JavaScript plugin, gRPC web plugin, and the Golang plugin. And here are all the outputs. All the outputs for these stubs will be in the gen directory. And how do we run that tool? In the repo, I've created two scripts, build.bat for Windows and build.sh for Unix. And here is the bash script. Here's what's happening. First, we are cleaning up the gen directory. What's been there will be wiped out. And yeah, the proto tool from Uber is actually a Docker image. And what we are doing is to create a Docker container using that image and executing a command called prototool, and that will format our proto files, will lint them, and finally it will generate the stubs into the gen directory. Let's have a look how this can be run. I'm going to stop the server for now, going to the API directory, and I'm simply calling the bash script. Waiting. Okay, no errors. And I hope you're curious what's in that gen directory. Yeah, here are the stubs for Golang and JavaScript. And let's have a look at the JavaScript stubs. As you can see, we have two JavaScript files, notifier API proto buffers and notifier API for gRPC web. And of course, their TypeScript definitions. Let's have a look at the notifier API proto buffers. You see this big text here, generated code, do not edit. Yeah, always use the Uber proto tool or the protogen tool provided by gRPC for generating the stubs. As you can see, for auto-generated code, it kind of looks pretty good. There are comments. Code is well formatted, readable, not minified, very, very nice. But still, it's not the way how you would write a JavaScript application. But after all, it's auto-generated, and yeah, nothing is perfect in this world. Similar situation here in the gRPC web proto buffers. This is what we will be interested in, the notifier API promise client, which will create a promise client that will be using to talk to our service via gRPC. Okay, so we have generated our stubs, and now I think it's time to consume them in our application. I'm going to close a little bit some tabs and get to the UI. And yeah, right now we have a simple application that we already saw here. with two input fields and a button, and the button is doing nothing. This is what I'm going to implement right now. I'm going to call the show notification RPC right here from the browser. Yeah, it's a very basic application so far, and we will need to write the client function here and the show notification API that our app will be calling. Before that, I will have to install a couple of dependencies because we will be needing them in order to properly consume gRPC web. But first of all, we need to include these auto-generated stubs from here into our UI, and I'm going to do that in the form of a node module. So in order to do that, I have to first create a package JSON here so I can add the metadata for my API module. And I'm going to yarn init, and the name of the module will be notifier API, not notifier API. Okay, version 1 is okay. Description node, entry point does not matter, repository, older license, private. Okay. And this is our package JSON so far. Right, let's get back to the UI directory, and we need to now install this API module as a node dependency, and also Google Protobuf and the gRPC web JavaScript libraries provided by Google. So I'm going to yarn at Google Protobuf and also gRPC web and also API. Installing dependencies, done. Okay, so here is our package JSON of the project, and you can see these are the two libraries that we'll need for the browser in order to consume gRPC APIs, and our notifier API, from which we'll be importing our stubs. Have a look at these options. This is the notifier API.proto. If you remember, our proto file was like this before the moment I showed you, and these options are auto-generated by the Uber proto tool, and they are basically options for different languages in which gRPC is implemented. And as you can see, these are mostly namespaces. All right, let's now get the implementation of the show notifier API call. This should happen here in the button. On click, we will be calling our show notification call, but before that we need to implement it. I'm going to create a new directory in my source called API, and we'll put an index here. Right now I'm going to put everything in this single file. And if you have a look at the repo in GitHub, it's organized much better. But right now, for simplicity, I'll be putting everything here. Okay, so we have to do two things here. First, we need to construct our gRPC client, and then we need to create show notification API. To do that, we need to import first our stubs. So I'm going to import them. Notifier API /gen/js/notifier API protobuf. And from here we import show notification request, and also from gRPC web .js we import notifier API promise client because we want to be modern and to use promises instead of callbacks. That's basically the difference between the two constructors. So both constructors will create the gRPC client for you, with which you are going to execute gRPC calls. But the first one is callback based, and this is promise based. Is definitely my preference here. Okay, so let's construct our gRPC client. Before that, we need to define our gRPC host, because we may communicate with our own domain, or we might be calling some remote server. In our example, this is the same domain, so I'm simply putting here window.location.origin, which should be HTTP localhost at port 4333, and we are constructing our gRPC client like this: const client equals new notifier API promise client. And as you can see, the IntelliSense comes pretty much in handy here. It accepts the host name as a string, and this is our gRPC host. And now let's create our show notification API. That's like this: export const show notification equals it's going to accept the title and the message. And now we need to shoot the gRPC call here. And to do that, we first have to construct our request, which should be an instance of this show notification request. As you can see here, it's show notification RPC accepts show notification request. So we have const request equals new show notification request. Okay. Now we need to set the title and the message to the request. As you can see, title and message. So what we are doing is calling request.set, and you see the IntelliSense here again in action. It's a set title, and it tells me that the value should be a string. This is our title parameter, and also request.set message, which is the message. Okay, our request is ready. Now we need to call the RPC, and that's going to happen thanks to the client. So our client implements a method called show notification. And this method accepts a show notification request, which is our request. And since this will return a promise, because our client is a promise client, we need to await the response here, like this. Response equals await, and our function is now async. And finally, we return our objectized response. And that's it. So as you can see, not very natural way for calling APIs from JavaScript, but still you can create wrappers around these calls and easily consume them in your applications. This is exactly what to do right now. I'm going to get back to my application and import the show notification from API. And here I will have to pass my title and message, which should be taken from the inputs. And in order to do that, I'm simply going to use the useState hook from React. A little bit of boilerplate here. Use state empty string, and the same for message. Okay. On change, we have to update the title. So title e.target.value. Okay, and same for the message here. Value equals message. On change, set message. Okay, and finally, by clicking the button, we call show notification with the title and message from the state. I'm going to save this, and I'm going to test this. Fingers crossed that it's going to work. So in order to test it, I first have to rebuild my application. To do that, I'll first have to rebuild the UI using yarn build. This is going to create a production build for me. Okay, So my build is here, the UI directory, in a build subdirectory. And now I have to embed this build into my Go application. For this purpose, I'm using a module from Go called static, which embeds static files into my binary. And this is great for creating applications in Go because you end up with a single binary and not having to bundle HTML and CSS and JavaScript files together with your service binary. Everything is in that single binary. So I am telling static to build everything from UI/build into my app. And finally, I'm going to build my service. And I'm going to finally run it. Okay, so running on port 4333. Quick refresh here, checking the browser console, no errors, which is great. Yeah. Now the moment of truth. Title, hello. And yeah, here we go. That's the system notification. So right now, our UI is communicating with our Go service via gRPC. How this happened? Let's go to the network tab and examine the network request. As you can see, here we have this show notification request, which is a simple XML HTTP request made by the browser. And as you can see, the request headers are that it's application gRPC web text. And yeah, the content type is application gRPC web text. And the most important part is the request payload, which is some base 64 encoded string, which if we decode it, didn't manage to copy it, so copying. Sorry, it was A to B. Yeah, you can see this is my payload. This is not very easy for debugging. That's why there is a browser extension called gRPC Web, and I strongly recommend it for debugging gRPC requests in the browser. It's available for Firefox as well as for Chrome. And if we get here and show our notification one more time, yeah, it should appear here. Let me refresh. Okay, the problems of the demo affect my extension is not working properly, but anyway, here you should be seeing this request. Let me Okay, let me try killing my browser, and hopefully this will start working. Fortunately, happens from time to time. Okay. See web. Nothing. Anyway, okay, so maybe it's because of the most recent version of gRPC web node dependency I've installed. Anyway, this extension is very helpful when it works, of course, to debug gRPC requests because it displays all the parameters and response data in a very nice and readable JSON format. Okay, so what's the best of gRPC and gRPC web? Well, right now I'm consuming my gRPC service from the browser, from the UI of my application, but it can be basically called by any other service or application that implements gRPC. I'm going to quickly show you an example with Bloom RPC, which is a desktop GUI gRPC client, and it comes in very handy for executing RPC calls via gRPC and debugging them. It's very easy to use. You first have to import your total definitions here. So it loads your API, and here you can see my notifier API, the notifier version 1 API namespace, and only one implemented RPC at the moment called show notification. And click here, it opens a new tab, and here is my request payload and my two parameters, the title and the message, and the response and the play button, which when clicked again displays this notification. So basically from anywhere, every application, every service that can implement a gRPC client can basically talk to your service over it. Okay, let me now check out the master branch. So I show you quickly the full version of this application. Let's do some cleanup here. So yes, let's go back to my editor and see the final version of my proto file. As you can see, there are two more RPCs right now. The show notification RPC will be used for previewing notification, but for scheduling notification, there is another RPC called schedule notification, accepting schedule notification request and returning schedule notification response, and also get notifications RPC, which returns a list of notifications that are scheduled. And yeah, the schedule notification request also accepts date time parameter as unit 32, which is actually a timestamp. And yeah, the Go service uses SQLite database to keep track of all the scheduled notifications. And yeah, let's quickly see it in action. As you remember, I need to build my stubs. I'm going to the API directory and run build. Then get back to the UI and install all the dependencies. And build. And now the static build in the service, and finally building the notifier binary. Waiting. Something is not right about it. Should be much faster. It simply takes too much time. That's unusual. Okay, so I'll leave it for now and get back to my presentation. So because time is running and I want to tell you a couple of more things. Okay, that was a very simple example. How about a real world example? Right now, we are heavily using gRPC in Chaos Group and specifically gRPC Web in one of our projects called Cosmos. Cosmos is right now in beta, and we will be releasing it very soon. It's a collection of 3D assets, and for its service we are using gRPC, so it can communicate with all the V-Ray plugins. For example, V-Ray for SketchUp, for Rhino, or for 3ds Max. And all these V-Ray plugins are communicating with Cosmos service through gRPC, and through that same gRPC, but specifically gRPC Web, this service provides a web UI, and it talks to the Cosmos service again with gRPC. It's pretty much a good architecture, I would say, because we managed to make this work. All the services are listening on the same port. For example, the static server that serves the bundle for the UI, the gRPC service is also listening on the same port. There is also a REST service, and all the communication is happening through gRPC. So we basically have one definition of that API, and every integrator or the web UI are consuming it. Finally, I'm going to give you a couple of tips and takeaways. In this demo, I just shown my protobufs and generated stubs are kept in the same project, but I highly recommend to keep them in a separate repo. This way you can make the generation and the length and everything part of your pipeline. The Uber Proto tool will definitely make your life easier in terms of generating stubs, documentation, linting, and etc. Because dealing with the tools around gRPC is a great pain, I would say. The gRPC Web DevTools extension is very handy. I'm sorry that it didn't work during this demo. I'm not sure why, but probably because the gRPC Web Node module got updated. The Bloom RPC GUI, which I showed you, is great for debugging as well. And finally, don't over-engineer it. If you need a simple resource-oriented API, just go REST. There's no need to make your life unnecessarily harder. And that was it. Thanks for listening. And once again, thanks to our sponsors. And I hope you enjoyed this session, and I wish you great time until the end of JSTalks. And that was all from me. Thanks for listening, and bye-bye.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I could see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, where the light ain't allowed to go. When the line gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
Is a wealth of the most advanced financial technology.
All right. What if I set the parameter for equities in the energy sector? And here,
William experts solutions to help him with his trading decisions because they react to market movements faster than a human. He talks smart gadgets the same way he talks to his friends.
Devexa, show me Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative helps him visualize his ideas in. But most importantly, DevX systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. Devexa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. Dev experts will be there.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripes forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.
Здравейте! Аз съм Симеон и съм софтуерен инженер в SumUp. Тук е доста яко. Можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, в супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
Hello everyone, I'm Jason Mays, developer advocate for TensorFlow.js here at Google, and I'm also joined today by Minko Gachev, who will be leading the second part of this talk. Now today we're going to be talking about how you can give your future web app superpowers by using TensorFlow.js in your existing workflows on front end. So with that, let's get started. But you might be wondering, as a web developer, why should I care about machine learning? First up, I just want to start by saying that machine learning could influence every industry out there. As web devs, we're in the unique position where the apps that we create could be used for any one of those industries. And so there's a good chance in the not too distant future, clients will ask us to use machine learning, as there'll be some unique benefits that we can get by doing this client side in the browser, as we'll see later. And we're currently at a very exciting time where machine learning is now being even more widely used. And we may even be entering a new age, which may allow us to make more human progress than we have done in the entire history of our existence. These are really exciting times to be alive, and now is the time to get started with machine learning, as there are only very few times in our lives we get to experience something as large as this. And on that note, there are many ways you can use machine learning. Things like object detection, such as recognizing an object in an image. Or what about regression, which basically means predicting a numerical value from some input. For example, what is the price of a house if the square footage is 1,000 square feet? With enough training data, you can predict this with machine learning. Or how about natural language processing to understand human language? With this, we can mark if a sentence on a blog post comment is toxic or not, or if it has a positive or negative sentiment. One could use this to assist in blocking trolls on a website before it even gets posted. Or how about audio for speech recognition? I'm sure many of you have many smartphones and tried the web speech APIs. All of this is powered by machine learning. And finally, we have generative and creative examples, one of which we can see on this slide, which was created by NVIDIA's recent research. Now, none of the faces in this animation are real. They've been dreamt up by the machine learning model. Just like if I asked you to imagine a purple cat, you probably could do so even though you've never actually seen one. Now, the machine learning here has learnt the essence of what a human face is composed of and is then asked to generate new ones. And TensorFlow.js is a machine learning library written for JavaScript. And doing machine learning in the browser has several advantages, such as lower latency, as no server is involved, user privacy, as the data stays on the device, and super easy deployment, because anyone with a web browser can use it. And that means you can use machine learning anywhere JavaScript can run, which of course, as we know, includes the browser, the server side, desktop native, mobile native, and even IoT devices. And if we dive into each one of these stacks in more detail, you can see many of the technologies we know and love. And JavaScript is one of the only languages that can run across all these devices without extra plugins, giving you the ability to deploy and run anywhere in one code base. And that's a great win for JS devs because you can make scaled web applications powered by machine learning in all of these environments, and maybe even control hardware from the browser or standalone if you wish. Now, with TensorFlow.js, you can run, retrain via transfer learning, or write your own models completely from a blank canvas. And with this, you can use it for anything you might dream up. Things like sound recognition, gesture-based interaction, sentiment analysis, conversational AI, and much, much more, as we'll see. Now, there's a few ways you can use TensorFlow.js based on your familiarity with machine learning, JavaScript, or both. The first way is to use our pre-trained models. These are easy-to-use JavaScript classes that can be used for many common use cases. There are loads of situations where you don't need to train a brand new model from scratch and instead can leverage an existing one. So let's look at some of those. Here you can see several popular pre-made models available with TensorFlow.js. Things like object detection, body segmentation, which is the act of classifying each pixel in an image to determine if it belongs to the human body or not, or pose estimation to understand where the joints and skeleton might be. And we even have many natural language models to understand human language too. In fact, our new question and answer model allows you to ask a question on any piece of text, and it can automatically tell you which part of that text answers the question. Imagine using that on a really long web page to scroll automatically to where the information is located relevant to what you want to know. You can do that right now. And we've got many more models you can check out in the link shown. So let's see some of these in action. Now, first up is object detection. This model is using something called Cocoa SSD behind the scenes and is trained on 90 common object classes. It can recognize those objects and images and provide us with the location of each object with a bounding box, as you can see in this image on the right of the dogs. Now notice how it can detect multiple objects at the same time too. This is different from image recognition, which understands something might be in an image, but not where or how many. And that's why Cocoa SSD is super useful here. So let's see it in action with a demo in the browser. So here you can see us running Cocoa SSD live on a web page. And if I click on any one of these images here, you can see that it highlights the objects is found within them, even if they're different classes. You can see here that this dog is very close to a bowl of treats, which might be useful to know if you want to send yourself an alert. Now, we can go even better than this by enabling our webcam. And if you do that, you can see me live speaking to you right now, and it's classifying me in real time at a high frames per second. And what's really cool here is that this is running all locally on my web browser. None of the webcam imagery is being sent to a remote server for classification, so your privacy is preserved as well. Next up, we have Face Mesh. This model is just 3 megabytes in size and has the ability to recognize 468 landmarks on the human face. Now, not only does it work super robustly, we're starting to see real-world use cases of people using this in production too. And on the right, we can see a demo face who's part of a L'Oreal group for AR makeup try-on. It should be noted that this lady is not wearing any lipstick. And here, our face mesh model is combined with WebGL shaders to augment the color chosen onto the person's lips in real time in the browser. So let's see face mesh in action, as it's a pretty cool model. So here is face mesh running live in my web browser. Notice how my face is being tracked whilst I'm talking to you right now. And on the left, we can show the mesh of our face in real time. But because this is JavaScript, not only are we doing the machine learning, we're also rendering a 3D point cloud on the right-hand side in WebGL that's fully interactive too. So let me show you that. You can see me moving the 3D points right now live in the browser, and super smooth too. Now you'll notice at the top left, I'm getting about 22 frames per second, but that's because I'm live streaming right now. And of course, if I wasn't live streaming, we'll get closer to 30, 35 frames per second at least on my current system. Now, JavaScript has a very rich ecosystem for 3D graphics and other charting, which is far more mature than other environments, which makes it super fun to prototype new ideas in the browser with machine learning models. And even better, we can choose what backend to execute on, such as the CPU or GPU, if we want to do so. And we can do this in this demo by clicking on the drop-down at the top right here. And that will give you a higher frames per second depending on the type of device that you're running on. And next up, we've got body segmentation. This model can distinguish 24 body areas across multiple bodies, all in real time. Now, this is hard to demo live as I need more space, but notice from the image how the bodies of each person are correctly segmented with different colors on different body parts. And even better, we can get the pose estimation too, those lines in blue, to estimate where the can do things like gesture recognition and much more. And with a little bit of imagination, we can emulate some of the superpowers we're promised from the sci-fi movies. And first up is invisibility. This is more advanced than simply replacing the background with a static image. For that, you wouldn't even need machine learning, of course. But notice here, when I go onto the bed still deforms in the right of the image. And as I move around, you can see that distort in real time, or how the laptop screen still plays. Now, this prototype uses body pics that we just saw to calculate where the body is not, so that it can eventually learn all the background and then keep updating the parts where it's safe to do so. And even better, this was made in just one day and runs entirely in the web browser. No background in machine learning is required to run the code, simply click a link and it just works. And no images are sent to the server for classification, leading to real-time results. Next up, lasers. Another member of the community in the USA combined his love for WebGL shaders and TensorFlow.js to enable him to shoot lasers from his eyes and mouth, just like Iron Man. And this uses the face mesh model we previously saw running in real time in the browser without issue. Whilst this is a fun demo, you can imagine how this could be used for a movie launch to amplify the reach, building a one-click creative experience for fans to then build excitement. How about teleportation? By combining TensorFlow.js with other emerging web technologies, we can now even create digital teleportations of ourselves anywhere in the world in real time. Here, I segmented myself from my bedroom using body pics, transmitted my segmentation anywhere in the world using WebRTC, and then recreated myself in a real-world environment using WebXR and Three.js. Now remember, all of this is running in the web browser, no app install is required, leading to a frictionless experience for the end user. Just click a link and it just works. And having tried this myself, it really feels much more personal than a regular video call, as you can walk up to the person in your environment and hear the audio from the correct direction as if they really were there. And maybe next time that I'm presenting to you at a future event, I'll be standing with you. And of course, there are many other delightful creations we can make too, beyond just superpowers. How about this clothing size estimator? Here, I created a tool that can estimate your clothing size in under 15 seconds in the web browser to automatically select the correct size of clothing on a website. Now, I don't know about you, but I can never remember my size of clothing. I go like once a year, and with a simple tool, I can enter my height, stand facing the camera, once to the side, and it can automatically choose for me the correct size at checkout, meaning less returns and less time wasted. This was created in just 2 days and can potentially be used by anyone with a single click at the point of checkout on our website. And finally, we have one more example from the community. Here, someone's managed to bring an image of a model from a magazine to life using WebXR and WebGL, and notice that even with his fancy particle effects and machine learning running, it's actually running on a 2-year-old Android device, and still performance is pretty decent. Now, the second way to use TensorFlow.js is via transfer learning, which basically means retraining existing models to work with your own data. Now, if you're familiar with machine learning, you can of course do this programmatically in code, but today I want to show you some easier ways to get started. Now, first up is Teachable Machine. This is super easy to use and runs entirely in the web browser for both training and for inference, which is the act of using the model to classify something. Now, the best way to explain this is with a demo, so let's try it out. So if we head over to teachablemachine.withgoogle.com, we're presented with a screen like this. We can see 3 types of projects we can use: image, audio, or pose. We're going to use image today because we want to do object detection. So click on that, and you then see a screen like this. On the left-hand side are the classes that you want to recognize. If you wish, by clicking Add a Class. But today, we're just going to recognize my face or a deck of playing cards. So let's go ahead and give them more meaningful names. So for class 1, I'm going to call this Jason. And for class 2, I'm going to call this Cards. Now, all we need to do is click on the webcam button, allow access to our cam, and now you can see a live preview. We can use this to sample that object. So the first one is my face. I'm just going to move my face around and take some samples by clicking this button below. And notice how I move my head around to get some variety so it learns what my face looks like from the sides and different angles. I've got about 36 images here, and I'm going to try and do the same with a deck of cards by clicking the webcam button below and try and get the same number of images. Otherwise, I'll have a bias in my system. So let's bring the cards nice and close and try and get 36 images of that as well. 35, that's good enough. So now I click on Train Model, and what's going to happen is behind the scenes, we're going to retrain the top layers of the model to distinguish the difference between my face or a deck of playing cards. And you can see in the time it took me to say that, it's already finished training. We've got a live preview on the right-hand side. Currently, it predicts Jason with 100%, which is correct. My face is indeed in view. If I bring the deck of cards into view, we can see it now predicts cards with 100%. Jason, cards, Jason, cards. And you can see how responsive that is too. Now, this is great for prototyping. And if this is good enough for your needs, you can click on Export Model at the top right there, click on Download, and now you can download the model.json file that you need to run in the web browser. You can then host this on your own website or CDN and use that in any way you wish with a nice graphical user interface and user experience. So you've seen a lot of great demos, but what are the benefits of doing machine learning in JavaScript? First, let's start by explaining the TensorFlow.js architecture. Essentially, you've got two APIs. The first is a high-level API known as the Layers API. That's very similar to Keras if you're using Python already. And next, we have a low-level API called the Ops API. This is a more mathematical API that allows you to do things like linear algebra, should you wish to work at that level. So let's see how these come together. Here you can see how our pre-made models sit upon the Layers API, which itself is above the Core or Ops API. Now, this lower level API can speak to many different environments, such as the client side, which includes things like the web browser. And each of these environments can execute on a number of different backends. For example, the CPU, which is always available, WebGL for GPU acceleration if supported, or WebAssembly, which is WASM for short, if supported for more efficient performance on CPUs. And there's a similar story for the server-side environments too, with Node.js. Note here that our Node.js implementation can talk to the same bindings that Python TensorFlow talks to, so performance is just as good or sometimes better than Python due to the just-in-time compiler of JavaScript. And the other thing to note is that if you're working on a machine learning research team who wants to deploy their research onto the web, there's a good chance that team might be working with the Python flavor of TensorFlow. And with our Node.js implementation, you can execute the saved models that they've produced without any conversion required, making it super easy to integrate. However, if you want to run a Python saved model in the web browser, then we've also got a command line tool to help to do that. This will convert the saved model to the JSON format required, but we need to use on the client side in the web browser. So to wrap up this section, there's 5 client-side benefits of doing machine learning in the browser that are worth pointing out. First is privacy. Inference is performed on the client machine, so no data is ever sent to the third-party server, which maintains data privacy for the user. This is particularly important for medical, legal industries, where it might be a requirement not to transfer data to a third party. And not to mention there's growing concerns around privacy these days, and here you can get it for free. Next up is lower latency. As JavaScript has direct access to the sensors on device, such as microphone, camera, accelerometer, and more, there's no round-trip time to the server to analyze that data. Latency could be close to 100 milliseconds on a mobile connection, but with TensorFlow.js running on device, we can go much faster. Next, cost. If there's no data being sent to a server, you don't need to hire all those expensive CPUs, GPUs, and RAM to be running 24/7 for inference. Instead, you just have to pay for the hosting of your website assets and model files, which is far cheaper. Of course, interactivity has always been a great selling point for JavaScript, and WebTech has evolved to handle even richer formats like WebXR and WebGL. So I encourage you as web devs to kind of see how far you can push machine learning models by combining that with the rich ecosystem that JavaScript has to offer. And then finally, the reach and scale. It's zero install. Anyone can click a link and get the machine learning for free. And that's all you need to do to run an ML demo in the browser. And this can allow you to use cutting edge research in novel ways that scales. So we're going to end with some resources to get started if you want to continue your TensorFlow.js journey. Essentially, if there's one side that you bookmark, let it be this one. This side has all the resources you need to get started. Our website and API available on tensorflow.org/js. Our models are also available to use. Today, we just covered 3 of them, but there's many, many more that you can also check out as well. We're fully open source, so check us out on GitHub, and we welcome contributions, of course. And for more technical questions, go to our Google group. We've also got some boilerplate code showing how to use our pre-made models in minutes over on CodePen and Glitch. If you're looking for an all-in-one book, then Deep Learning with JavaScript by Manning is a great book to go to. It's written by folk on our team, and the only thing is you need to understand JavaScript. There's no background in machine learning required to read this book. And a quick shout out to our community. Check out Made with TFJS hashtag on Twitter and LinkedIn to see many more amazing examples that people have been making. New content's coming out every week, and this is a great way to get inspired. And if you make something with TensorFlow.js, use the hashtag for a chance to be featured at future events, such as our show and tells here on YouTube, and even on our blog posts. And finally, the only question left is, what will you make? This final example comes from a community member in Tokyo, Japan. By day, he's a dancer, but he's managed to use TensorFlow.js to create this amazing hip-hop video with some awesome video effects using body pics. And the reason I show this is that machine learning really now is for everyone, and we're super excited to see how TensorFlow.js will enable more people to start their journey with machine learning. Creatives, artists, musicians, even web devs, no matter what your background, you can use these models in ways never dreamt up by the original model creator, as you saw from just a few of the demos today, and we're super excited to see what you create. So do use the hashtag so we can find your work. So that wraps up my part of the presentation. Feel free to stay in touch. I'm available on Twitter and LinkedIn. And of course, remember to use that hashtag Made with TFJS if you make something cool. And now I'll hand over to Minko, who will show you how to integrate this with Angular web apps. Over to you, Minko.
Jason, thank you very much for this really thorough introduction to TensorFlow.js. My name is Minko Getchev. I'm working in the Angular team at Google. And in this part of the presentation, together, we're going to build an application that we can control by using hand gestures through our camera. For the purpose, we'll be using TensorFlow.js and its hand pulse model. Before getting started, let us look at a quick demonstration. See how when I wave with my hands to the right, I open the side drawer. When I show two fingers, I select the second link with my thumbs up. I navigate to the page referenced by this link. And finally, waving my hands to the left hides the drawer. So let us build this together. First, we'll create a new Angular project by using the CLI. Today, we'll be using the router and we'll be declaring styles with CSS. Engineer will scaffold the application and install the project's dependencies. Next, let us go to the project's directory and add Angular material. The ng-add schematics of material will prompt us to select a color scheme and integrate the package with our project. As the next step, we can start a development server by running ng-serve. When we open the browser, we will see the default CLI app is up and running. Now let us open the template of app component and replace it with the markup we'll be using for this example. Here I'm using snippets to quickly create the structure. At the top, we have a mat drawer with two links to a home and an about pages. Inside the drawer, we have a router outlet where we'll be rendering the individual routes that we're going to add in a few minutes. After that, we have a button. When the user clicks on this button, we will open the drawer. At the bottom, we have a video element and a canvas. We will use the canvas to render users' video and the output of our machine learning model. The video we'll be using to show the output of the user's camera. Now let us import the siteNav module in app module to make sure that the mat drawer component is available. Notice that the app components template, we've bound to a few missing properties. Let us add the missing properties to the app components controller. First, we will declare a stream property of type MediaStream. After that, we will declare two observables, opened and selected. Next, we will go to the app component styles and quickly improve the design of the app. Opening the browser, we can preview the changes. See how clicking on the button opens the left drawer. Well, now we're missing the two routes, home and about. The Angular CLI offers a command that lets us declare them as lazy loaded routes. We're going to first go to the terminal and now run ng generate module about with route about and app module as its parent module. We'll do the exact same thing for the home route. Here we have the two components that we just generated. If we now go to the browser, we'll be able to navigate to the routes and see the rendered templates that are associated with the corresponding components. Let us now go to the app routing module and declare a redirect route to the home path. We will be redirecting the user to the home path when they open the application for the first time without having a path specified. As a next step, we can add content to the about component. To make the content more visually appealing, we're also going to add a few styles. In the home component, let us show an image with the Nyan cat. All right, so now when we navigate between the two routes, we're going to see the rendered templates that we just created. Cool, now it's time for the very fun part. We'll be using TensorFlow.js for our machine learning model. For the purpose, we'll first need to install a couple of packages. TensorFlow models, handpulse, TensorFlow core, a converter, and the WebGL backend for TensorFlow. When the module's installation is complete, we can restart the dev server of the Angular CLI. After that, let us open VS Code and define the service, which will encapsulate all the machine learning logic. We'll call it hand gesture service. I've prepared a snippet for here as well, but we're going to go through the few main areas of this implementation. See how we first declare the class as a tree-shakeable provider. This way, we can inject this logic in the app component. Notice that we also have two properties here. We have swipe, which is the observable we're getting from the underscore swipe behavior subject. We'll be using it to emit swipe gestures. When the user waves their hands to the right, we'll emit right swipe gesture. When they wave their hands to the left, we'll emit a left swipe gesture. We have the same set of behavior subject and an observable for hand gestures. When the user shows one finger to their camera, we'll emit 1. When they show 2 fingers, we'll emit 2. And finally, when they show a thumbs up, we'll emit OK. We also have a getter for the media stream we are receiving from the user's camera. Next, we have an initialize method, which accepts a canvas that we will use to render the output from the camera and the ML model, and also a video element. In the initialize method, we get the user media, and after that, load the machine learning model. Here we'll be using handpulse, which recognizes hands and returns also the hands together with different landmarks, for example, the positions of the individual fingers. Next, we have a run detection function. Inside of it, we basically query the model and render its output onto a canvas together with the user's video frame. Notice we also pass the model's output to the methods process and process gesture. They will be analyzing the result of the invocation of the model based on the coordinates of the landmarks that we received. After that, if they recognize a swipe, for example, a hand wave, or any of the gestures, such as 1, 2 fingers, or thumbs up, they're just going to emit events via the observables that we declared above. For our purposes, we'll be using the library fingerpulse for hand gesture recognitions. Well, before that, we'll have to install it by using kr. When the installation is complete, we can go back to VS Code. In the final part of this video, we're going to update app component to use the hand gesture service and control the UI from there. First, let us inject the service and the router in app components constructor. Next, we can replace the stream property with a stream getter, which gets the camera stream directly from our hand gesture service. We also need to get references to a few elements. We need to get a reference to the video, to the canvas, and to the two links associated with the home and about pages that are in the actual drawer. For the purpose, we'll be using viewChild and get the associated element refs. As a next step, we'll get the swipe stream from the gesture service and filter only the swipe left and right events. We want the drawer to be open only when the user swipes right. So let us map this to true. Next, we want to do the same thing for selection. First, we'll filter only the 1 and 2 finger gestures. After that, map the 1 finger gesture to the home page, since it is the actual first link in the drawer. And 2 finger gesture, we're going to map to the about page, which is the second link there. Now let us initialize the model. Since it uses the canvas and the video elements from the template, we need to make sure that these elements exist. So for initialization of the model, we're going to use the ng-after viewInit lifecycle hook of the app component. Well, now let's open the browser and see what we have. See how when I wave my hand to the right, I open the drawer. And when I wave it to the left, I close it. How cool is that? The only functionality left is to navigate across the application by using the 1, 2 finger gesture and thumbs up. In the constructor of the component, we want to handle the thumbs up, which is the OK gesture. We'll pipe the gesture observable and filter all the incoming values so that we can get only OK. Once we get an OK gesture, we would want to get the latest value from the selection observable, which could be either home or about. We'll subscribe to the result and navigate to the corresponding selected page. Finally, let us preview the result. We can wave with a hand to the right to open the drawer just like we were able to do before. However, notice right now, after we show 2 fingers, the application selects the About link. To navigate to the About page, just show thumbs up and wave with the hand to the left to hide the drawer. Well, that was pretty much everything. Thank you very much for watching. You can find the associated resources with this video in the description below. Until next time, and happy coding!
Здравейте, аз съм Симеон и съм софтуерен инженер в SumUp. Тук е доста яко, можем да експериментираме с различни технологии, да пишем на различни езици, като Ruby, Erlang, Elixir, каквото намерим за добре. Работим в малки екипи, в супер готин офис и според мен правим най-добрия продукт на пазара. Винаги си даваме отворена обратна връзка и винаги можем да бъдем себе си. Искате ли да сте част от екипа ни? Присъединете се към SumUp.
I'm a freak, I'm an outcast, I'm a shadow. I stand with the lost souls, looking for a hustle. Got a pulse on the streets, I'm the one you won't look in the eye, no. Yeah, well, I can see what's headed for you down that road. And soon it's coming to take everything you know. When the monster crawls out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadows, where the light ain't allowed to go. When the line gets a little blurry, you're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the line gets a little blurry, gonna need somebody like me. When the monster grows out of the sea, you're gonna need somebody like me. When your brother's got blood in the streets, you better call somebody like me. I was made in the shadow, where the light ain't allowed to go. When life gets a little blurry, we're gonna need somebody like me. Better call somebody like me, 'cause you want somebody like me. When the lines get a little blurry, we're gonna need somebody like me.
William is a wealth manager. He uses the most advanced financial technology.
All right. What if I set the parameters to look for equities in the energy sector? And here, alert set.
William trusts DevExpert solutions to help him with his trading decisions because they react to market movements faster than a human. He talks to smart gadgets the same way he talks to his friends.
DevExa, show me Earth Petroleum Inc.
Okay, the chart is open.
And they respond right away, even to his gestures. Ted is an investor. The technology he uses makes him one of the most successful people in his market space.
Answer the call. Hi, William.
Hey, Ted, how are you?
The innovative technology helps him visualize his ideas in real time. But most importantly, DevExpert systems help Ted act ahead of his competitors.
So, what do you think?
I think we need to react fast. DevExa, buy 10,000 shares of Earth Petroleum.
And make profitable decisions. Innovative trading software is about to disrupt the financial industry. DevExperts will be there.
Hold up.
Stripe Bulgaria was founded in 2008 by the Dutch entrepreneur Koen van Wijk. His vision was to create solutions that exceed customer expectations. Since 2014, Stripe is part of the ICT Group in the Netherlands. ICT Group is a stock-listed company on the Amsterdam Stock Exchange and employs more than 1,000 professionals. Since 2017, I have the privilege and honor to drive Stripe forward in the role of CEO. Together with 200 professionals, we offer solutions to our clients in digital transformation, smart applications, and infrastructure. Our mission is to build smart solutions that create business impact. We are Stripe.